Hi, this is Sean from the Unity Partner Engineering team. Unite has returned for 2023 and we have a lot of new exciting updates and announcements that's just been made. So for today, from 10 a.m. to 5 p.m, we have 7 sessions lined up for you. There are 4 in the morning and 3 in the afternoon. The first session is the Unite 2023 Keynote from 10 a.m. to 11 a.m. It's challenging to go into detail, but it promises to showcase some of the new groundbreaking tools and pivotal announcements that I'm sure all of you will be excited about. Next, we have the road ahead for game development with Unity from 11 a.m. for 50 minutes. This session goes deeper into the content introduced in the 2023 update. Broadly, it covers graphics-related topics such as the adaptive probe volume and shader graph updates. We'll also talk about XR-related topics such as the Apple Vision Pro, MetaQuest 3 support, as well as multiplayer and AI. Starting from 12 p.m, we'll continue with a session titled Instantly Get Your Game to More Players on the Web. Development for the web platform has been quiet for some time now, but we're renewing our commitment to leveling up our tech stack and building support for the latest technologies including Web GPU. In the last session of the morning, it's all about creating efficient editor and runtime interfaces with UI Toolkit. UI is a crucial aspect of any content, and Unity is striving to evolve in the direction where anyone can conveniently create UI. The complex usage of UXML and uQuery has been improved with an incredible and convenient binding method, reduced code complexity, and improved readability. Next in the afternoon session will start at 2:10 p.m. The first session of the afternoon is a popular topic, optimization. This session is all about improving app performance with the new memory profiler. It provides even richer information about the memory status of your games, explains the impact on application performance caused by memory usages, and also suggests solutions to your problems. The following session after that is titled Everything You Need to Know About Unity PolySpatial and visionOS, which includes information about Apple Vision Pro. Although the actual product hasn't been released yet, it covers the process of building for the much anticipated Apple visionOS. In the next session, starting at 4:10 p.m, titled Prototype a 2D Game in 20 Minutes with Unity Muse. As you may have heard, Unity is focusing on AI technologies, and this session involves Unity Muse creating prototypes by generating 2D images, specifically textures and sprites, right within the editor. If you have any questions, feel free to type them out in the chat. Our Unity team will try our best to answer all of your questions live. And now, let's start our Unite 2023 APAC on Air. Enjoy!
You got what it takes to go head to head. Cool.
morning, everyone. Welcome to Unite 2023. It's fantastic to be back together again live. And I have to say, having been at the Heineken experience last night, I am very impressed that at this time of morning, the place is full. So give yourselves a round of applause for actually making it here. So I'm Jim. I'm Unity's new CEO, and I am truly thrilled and honored to be with you here today. Most of you don't know me, but I'm going to try to remedy that through the course of this event. I'd love to meet as many of you as possible, either today at Unite or certainly over the next few months to get to have an opportunity just to kind of get out and listen and hear. I've been so inspired with the people I've met so far, the passion in this community. Look, I didn't come from gaming, but the highlight of my career so far was the opportunity to run an open source company called Red Hat, which, if some of you may know, is kind of a leader in Linux. And I have to say, I know there are differences, but the Linux open source community and the Unity community do have a lot in common. At Red Hat, we talked about democratizing information and content. At Unity, we talked about democratizing game development. And I'm here because I am so excited to and inspired by the opportunity to lead an organization that's truly mission-driven, and an organization that its boundaries really go well beyond the actual boundaries of the corporation, right? It includes a passionate community of contributors, and to me that is so inspiring, and so I'm so happy to be with you here. I've been amazed at the passion around Unity, both inside the company and outside the company, and it really does kind of get me up and get me excited to be part of something like that. I know I still have a lot to learn, and I'm in extreme listening mode right now, which is why I'm so excited to be here in person and have a chance to meet many of you. But I do want to address one kind of question that I've gotten over and over again, and that's around the runtime fee. I know that's probably, I hear a groan already. Sorry about that. Look, my simple answer is that as a catalyst in this extraordinary community around Unity, we have an obligation to engage with our community when we make decisions that affect you. Now, I'll be upfront, engaging in the same thing as consensus, but we should never, ever surprise you with a decision that has a material impact on you that you don't know about, right? So that's something I will commit to you going forward. Look, I know trust is something that's earned. It's not what we say, it's what we do. So going forward, we will demonstrate that behavior to you and with you as we make decisions about Unity in our community going forward. We'll also show you our commitment to delivering the best possible game engine ever. And coming up, you're going to hear talks about how over the last year we've used your feedback to better support you through the game development lifecycle. And after the keynote, we have some incredible technical sessions lined up that I highly encourage you to attend. Look, I'm so excited about today, and I can't wait for everyone to hear what we have in store. So I hope you have a fantastic Unite. And with that, Pierre-Paul, take it away.
Thank you, Jim. So Unity began as a game engine and a creation tool. But we all know that game development doesn't end on launch day. It's an ongoing process. Games need updates, new levels, and content. They have to work on all the latest operating systems, device models, and platform. So today, we'll share what we're doing to ensure that you have a complete, reliable platform to build, ship, and run great game. The editor's extensibility and a robust ecosystem of third-party tools offer you more freedom in how you create. Unity 2022 LTS, our long-term support release, is one of our fastest adopted versions to date. And since its release, over 1 million of you have chosen this version for its underlying stability and its awesome features. for everything from rendering to performance, as well as platform enhancement. And one of the biggest highlights is Dots, which delivers a data-oriented approach to coding to enable bigger, more ambitious projects. And we've implemented Dots so that you can use it alongside game objects. You choose which approach to use and when. And we've been sharing our excitement about Dots for a few years now. But as of the 2022 LTS, it's fully supported and production ready. So let's see how you are already using it to do amazing things in your games. So our friend at Tuatara Games introduced us to Bear Butt Boxing, a multiplayer network game that unleashes physics-based chaos and humor across devices. And with Dots, they could make system modular for greater flexibility. This allows them to test gameplay ideas without weeks of rewriting code. And with ECS, they could adjust their runtime data layout easily without impacting their serialized data. Building with Dots makes it easier to deliver performant experience as they start bringing the games to console. And then there's Hostile Mars. This is an upcoming base builder with intense combat from Big Rook Games. It features thousands of enemies on screen at once, each rendered in real time with pathfinding, collision detection, and the ability to react to the game's destructible environments. It's an ambitious game design that hits 60 frames per second, and it's powered by Dots ECS. And we're continuing to polish the feature set for Dots and the entity component system, including updates coming in early 24, like improvements to iteration time, more robust baking support, and scheduling enhancement. But for now, let's dive a little deeper into tools and features that you can use right now. And we're going to start with the Universal Render Pipeline, or URP, which powers stunning visuals across the broadest range of player devices. So here's Steven, who's going to show you what our latest graphic features can help you achieve.
Helping you get started with Unity is very important to us. So today, I will show you how we are helping you onboard on new features with the Universal Render Pipeline. So today, here is the new URP sample project that is delivered for you so you can learn how to use Unity more easily. This includes 4 scenes, each in a different art style, with varying levels of rendering complexity and platform performance needs. This means that you can explore new features delivered with the Universal Render Pipeline in several environments and learn how to use them performantly across platforms. Let's take a closer look. You start your journey in a scene we've named the terminal. This is where you can drop your assets and explore them in a calibrated environment. My kids love gaming, of course, who doesn't? And they really enjoyed test driving this scene and feeling like they were building their first game. It is very useful for look development and material adjustments. Next, you can teleport to other environments, like this stylized scene we've named the garden. This scene uses many features, including decal projectors, dot crossfade, and temporal anti-aliasing. For high-end mobile devices, you can take advantage of the Forward Plus rendering path, allowing you to display dozens of real-time lights. I have this scene running on my device here. Look. As you can see, walking around this environment really gives you a close-up view of the features we built into this scene. On iPhone 13, the garden runs at 60 frames a second. For less powerful devices, we've optimized both the garden and the terminal so they can run at 30 frames per second using the deferred rendering path. Now, Let's move on to a scene we've named Oasis. This environment is designed for higher-end devices and relies on more advanced shaders for vegetation, fog, sand, and water. We've also included an example of speech vegetation, and this is a highlight of this level. Here, you can learn how we've applied a custom shader with subsurface gathering and wind support. This is a great example for the high visual quality you can achieve with the universal render pipeline on more performant GPUs. Of course, multi-platform development is very important, so this level targets handheld, high-end mobile, PC, and console. And I have this scene running on my device here too, look. This scene runs at 60 frames a second on this iPad Pro and demonstrates how you can achieve visual quality like this. And finally, we haven't forgotten about VR. The final scene I want to share with you today is named The Cockpit. This is tailor-made specifically for standalone VR devices like the MetaQuest 2 and beyond. Here, we've developed a custom lighting model for you to learn how to customize URP. That's just a taste of what you can achieve with the Universal Render Pipeline. You can download and explore the URP 3D sample project with all 4 scenes today. But now, let's pivot for a moment and look to the future. Here's Pierre-Paul once again to introduce what's next for Unity.
So the next major release of Unity is coming in 2024. And we're bringing back the clarity of our original release naming into one powerful, polished version. I'm proud to announce Unity 6. At its core, the Unity engine is still the same editor, runtime, and APIs that you've been helping us build with your feedback. Unity 6 will be our next long-term support versions, coming to you in 2024. And this release will help you deliver advanced visual with astonishing performance, accelerate multiplayer game creation and scale, explore new creative possibilities with AI tools, and reach players anywhere with next-level mobile features and innovative XR device support. We're incredibly excited about this one. So I'll pass it over to Elaine and Mathieu to give you a preview of what's ahead.
Thanks, Pierre-Paul. Rendering will be a core pillar of Unity 6, with a focus on finding ways to help you get the most out of hardware. We're innovating to maximize the use of device CPUs and GPUs so that you can push visual quality and scale to create larger, richer worlds as efficiently as possible. Let's take a look. We'll start by giving you a bird's-eye view of Fantasy Kingdom in Unity 6, a world that we've adapted and expanded from a project by asset store publisher Cinti Studios.
Woo!
A small team put this demo together in just a few weeks. You can see Matthew's still working on it here, adding in a nice windmill.
Yeah.
Just watch out for the cow there, Matthew.
Okay.
What do you think? Are we ready?
I think they're safe here. And let's go.
Okay. So the first thing you'll notice is the scale of this demo and just how much is going on. But there's still really lovely, high-quality HDRP visuals and great performance. Now, it wouldn't be possible to render a scene of this scale at this performance level in Unity without our new rendering technology stack. Let's turn everything off and look at some numbers. Okay, so now we're running at around 18 frames a second. Not great. First, let us introduce the GPU resident drawer. With this, we've removed the CPU rendering bottleneck in current projects by reducing the number of batches. From this heavy point of view, we have around 137,000 batches. So watch what happens to the batch numbers as Matthew activates it here.
You ready?
Okay, way better. Now we're at 13,000 batches. That's only part of the story. We also need to look at the vertex count. Even with the reduced batches, we still have 47 million vertices. To improve this, we've added completely new GPU occlusion culling. And this makes sure we're not rendering things that can't be seen. When Matthew activates it, our vertex count drops from 47 million to 40 million. Okay. Now this happens dynamically. So maybe, Matthew, we can add something in front of the camera so people can see.
Like this.
Nice rock. Okay.
It's like it's the first virtual photo bump.
So you can see, you can see now even more vertices are being culled. We're down at 29 million now. And you don't even have to prepare your content. So using the GPU resident drawer and GPU occlusion culling together, we went from 18, 19 frames a second to 44 frames a second. And so with both of these together, it's almost like having a go fast button for your game objects. Remember, this is just in the editor. In your builds, it will be even faster. So you'll notice there's a lot of clear, crisp detail in the scene. Our new state-of-the-art spatial temporal post-processing, which we're calling STP, is doing a lot of the heavy lifting to make space in the frame. This is a novel upscaler that achieves super fast performance on each hardware tier, as well as uncompromising visual quality. And it works well across a very wide range of platforms. Let's go back and turn it off for a moment. Okay. So now we're rendering at 100%. Maybe we can crank up the post-processing effects just to really stretch the GPU a bit.
Ooh,
okay, right.
That hurts.
Yeah. So now you can see the GPU struggling to maintain the performance, and we're around 25 frames a second. Let's make our STP upscaler render at 65%, and watch what happens.
That's better.
Now, our frame rate goes up to 45 frames a second, and there's no loss of quality. So here, the GPU is doing 65% of the work, and we're still getting 100% of the quality. Now, one of the coolest things about STP is that it runs on high-end compute-enabled mobile, and this is a game changer. So using the GPU resident drawer, we were no longer CPU bound, and we almost doubled the frame rate. With GPU occlusion culling, we drastically reduced the number of vertices. And when our content was GPU bound, STP gave us performance improvements of up to 50%. This new rendering technology stack is going to make it so much easier for you to get through the last mile before shipping. You don't even need to change any of your existing content. That's for both URP and HDRP. So as we move through the scene, look at how beautiful this lighting is. All the indirect lighting in this scene is using our new probe-based lighting system called Adaptive Probe Volumes, or APVs. Maybe, Matthew, we can show the global illumination so people can see it?
Global illumination.
Okay.
Yeah.
Okay, so normally for this, you'd need to bake light maps and place probes by hand. But right now, every one of these probes you can see has been placed automatically, which is essential for an environment like this at scale. And watch the characters as they move around. They're dynamically lit by the light bouncing off the environment. APVs work for any objects in your world, and all of this helps you iterate quickly while set dressing. These will be production ready in Unity 6 for both scriptable render pipelines. So as Matthew moves around, check out the trees, foliage, nicely stylized, some subtle wind animation. We've made these with SpeedTree. We're upgrading our SpeedTree integration in the editor to help you take advantage of all these rendering improvements we're showing you today. With Unity 6, even your existing SpeedTree assets will see a big performance boost in both CPU and GPU sides. Look, there are hundreds of trees rendering in this scene. And what you're seeing is on a commercially available desktop. But with Unity 6, you'll be able to tap into these performance and feature benefits across platforms, including mobile. With Unity 6, it's now going to be possible to reach more platforms without a huge content reauthoring burden. So you'll spend less time optimizing every asset trying to hit your target frame rate. But before we finish, let's just enjoy the lovely view and one more very cool feature, which would have been really hard to achieve without APVs. They allow you to bake multiple lighting situations. And you can even blend between them at runtime, just like we're doing here. And so it's this simple. This simple to transition between day and night in your games. Even just a few of these new features like STP, GPU occlusion culling, and GPU resident drawer let you do a lot more with less cost. Pretty great stuff, right? All of this is going to make it easier for you to deliver more content. And while today you saw this demo running on HDRP, all of these features will be supported on URP as well, across platforms, including high-end mobile. We'll have more to share early next year. So, you've seen how we're evolving the editor, dots, engine, and render pipelines. Now, let's jump into what we're working on to give you end-to-end multiplayer solutions. Here's Adam to tell you more.
We all know that multiplayer games are hugely popular and that they're technically challenging to get just right. No secret there. But there are just so many elements that have to come together. You need smooth performance across all platforms, back-end infrastructure that scales with your success and your players, effective matchmaking and player communications, and a fun, socially engaged community that keeps coming back for more. Here's what we're building to help you nail your tech stack at every stage of development. With Unity, you can create, launch, and scale multiplayer games with the convenience of an end-to-end platform, backed by both our engine and our gaming services. And our netcode packages offer you the choice between simplicity for casual co-op games or more complex scenarios, such as competitive action genres, all with scalability and performance in mind. Features are flexible and extensible by design. So you can choose to build entirely within Unity's ecosystem or mix and match to get just the right tech stack for your game, your team, your vision. Now, I want to give you a sense of what Unity's multiplayer tools can do together. We've reimagined the Megacity demo with multiplayer capabilities. The original Megacity demo is based on HDRP, targeting high-end platforms. But we wanted to show you that this level of gameplay is possible for you across all platforms. So we've refreshed Megacity's content to give it a new look, and we've ported it to the universal render pipeline. And today, I'm thrilled to unveil Megacity Metro, a competitive and cross-play multiplayer sample for over 100 players. This sample showcases multiplayer gameplay on our services working together on everything from low-end mobile devices to high-end console platforms. Megacity Metro demonstrates server-authoritative gameplay with prediction, interpolation, and lag compensation. It's based on dots, including native netcode, physics, and rendering. It's also pre-integrated with several of our gaming services, including authentication, multiplayer hosting, matchmaking, and Vvox voice chat. So you can see the benefits of using a single ecosystem of tools from creation to live game services. Stay tuned for the full release in 2024. We love seeing you leverage this ecosystem in your games. And we've watched so proudly as you've scaled up to match huge player volumes in games such as Ship of Fools from Fika Productions, Turbo Golf Racing from Huge Cap Studios, Rogue Company from Hi-Rez, and more. Let's hear from Jamel Ziadi from Sticky Lock Studios, based right here in the Netherlands, about his team's experience creating a multiplayer, fast-paced shooter in Unity.
Thanks, Adam. I'm happy to be here to tell you about our new game, Hystera. It's a free-to-play arena shooter for all skill levels, and it has a lot of features of traditional fast-paced FPS multiplayer games, but we added a unique mechanic called the glitch, where a section within the level transitions to a completely different era, with its own playing field and its own behaviors. Each era also has its own unique weapon sets. It's a very unique battlefield, and we're really focused on getting it right. For an ambitious project like Hystera, we knew that peer-to-peer networking wouldn't be enough for our needs. We were also a very small team at the start of production, and we didn't have a lot of networking experience. There were simply not enough dedicated networking solutions in the market to suit our needs, and we decided to jump in and give Dot's netcode a shot. Despite the initial learning curve, it has served us well. We also chose multiplayer UGS because we wanted to have a third party take care of all the complex logic for us so that we could focus on the core gameplay of Hystera. We also use quite a few services from UGS, and it's very useful to get them with one single provider. There's less glue between various services to worry about, and it's also helpful to be able to escalate an issue to the multiplayer hosting team, and they can send it through to the matchmaker support when it's more related to matchmaking without us having to reroute that question ourselves. This matters because our mission is connecting people through digital experiences. We want players to feel as there's a lot of fast-paced action within Hystera. We want them to be on their toes, and working with Unity multiplayer tools helps us to do that. Be sure to check out Hystera on Steam, going into early access in 2024. And with that, I'll pass it back to Adam. Thank you.
Jamel, Hystera looks completely awesome. If you're in the room right now, if you're watching online, I hope you're adding it to your wish list. You better be. But successful multiplayer titles, they need so much more than just amazing gameplay. To take off, they need to offer a great, active community. In a recent survey, 67% of gamers stated that toxic encounters have at times caused them to stop playing their favorite games. So it's worth thinking seriously about how you can offer an engaging social experience that's safe, inclusive, and harassment-free. We've built safe voice and moderation to help you build and maintain healthy in-game communities. Safe Voice uses advanced machine learning algorithms to detect in-game toxicity, so moderators have the context and the insights they need to resolve incidents as they occur. Both are currently in open beta, so we can continue helping you overcome the challenges of offering your player fun, social multiplayer gaming experiences, and we look forward to doing just that. Up next, Victoria is going to walk you through some time-saving quality of life enhancements.
Hello, Unite. It is so great to be here. So far, we've talked a lot about Unity's creation tools. But now, let's take a look at how you work. Through more than a decade of developing studio pipeline tools, I've witnessed how challenging it is to keep everyone on track across distributed teams, and to organize content across projects and pipelines. So, we've been working on a platform of connected products and services to help bring order to the chaos of game development. And today, it's ready for you. Welcome to Unity Cloud. It brings together tools for digital asset management and live gaming services. It centralizes admin capabilities with better workflows and integrations into the editor, so you can understand and organize your game's entire lifecycle in one place. Let's take a look. We'll start with the Unity Asset Manager, which helps you track, manage, and share all your game assets. Now, when a new model is ready, it has much simpler to make sure everyone has the most recent version. Here's how easy it is to get started with Asset Manager. In the UI, you can drag and drop the model and associated files into a collection, and Asset Manager generates previews, details, and descriptive tags. Now your team members can see the new model with an embedded 3D viewer that supports fast and easy asset previews, even for the largest 3D models. Asset Manager integrates directly into Unity version control. There's no need for extra steps to upload or ingest your files. Teams can browse existing content across projects and avoid context switching between applications. So your team will be able to preview and access assets right where they work. You can get started with Asset Manager today in open beta. Next, let's see how connections between the editor and cloud projects support a LiveOps workflow, like pushing new content into your game without disrupting the player experience. From the hub, you can now connect to a cloud project with just a couple of clicks. In the editor, you can make an asset addressable, then create a content-only build using build automation. That's our continuous integration solution to automate multi-platform builds in the cloud. Next, we can use cloud content delivery to push updated work to players. There's no need to install a new version of the game. My personal favorite part of cloud is our new dashboard. It's less cluttered and more personalized. You can view your project status, and it suggests products and services to help you get your job done. Basic admin tasks like adding users, adjusting permissions, and aggregating product use can take up a lot of time. We've made it 80% more efficient. This work used to happen behind several different logins, but now you can do it all from one centralized dashboard. And starting today, Unity Cloud is in early access, so you can get started right now. This is just the first step. We have big plans for Unity Cloud over the coming months to deliver the integrations, tools, and workflows that help you accelerate your game's development and lighten your team's load. Next, Liz is going to show you some impressive features that can help you speed up iteration on your game art.
Thanks, Victoria. Earlier this year, we introduced you to Unity Muse, which provides powerful AI capabilities to help you ideate and iterate faster while staying in control of your work and your vision. It reduces friction, giving you more freedom to explore more concepts as you refine your work using natural inputs, like text prompts, vocal instructions, or sketches. So you can spend less time building inflexible and time-consuming prototypes and more time refining your ideas. Let's look at what you can do in Muse today. The sprite function enables you to generate assets with variations. So say you're stuck on what you'd like a potion to look like in your game. You can cruise dozens of assets and then select and polish whichever works best in your project. Muse can also generate high-quality 2D and 3D textures that can be applied to objects anywhere. And if you hit a bump in the road on your creative journey, you can use Muse's chat interface to source answers and resources across Unity. It can even generate usable code for your builds. These project-ready assets are created in the Unity editor, so you can drop them directly into your scene. And Muse produces assets with our custom-built, responsibly trained model, so you don't have to worry about accidentally generating someone else's copyrighted materials. In fact, we're so confident in how we're training our models that we're committing to supporting Muse content in production. In the unlikely event of copyright challenges, we'll partner to defend you. But just describing Muse isn't going to do it justice. So let's bring Charles up here to show you just how easy it is to explore different moods in a game using Muse's texture capabilities.
Thank you, Liz. Hello, Unite. Wow, there's so many of you. Okay, let's imagine that we're making a game together. It's a realistic game. We've blocked out everything. We like our setup. And now it's time to bring this environment to life by applying some textures. And we're going to use Muse Texture to do that. Follow me. Okay, so this has kind of got a brutalist, minimalist vibe going on. So my first material choice here, I'm going to go with a polished concrete floor. I think that's going to work well with both those architectural styles. All right, so here we go. So let's go with a little bit of an olive green concrete. Such a loud keyboard. And we're going to muse right now. It is musing, and let's see what we get. Come on, Muse, give us something great. All right, so these are looking great pretty much out of the gate. Liz, any of these standing out to you? I kind of like this one here. You should like this one, too.
I kind of like the one below it.
The one below? This one?
Yeah.
This one's got too many lines.
Okay.
With this one? Let's stick with this one. Follow me with this one. Okay, so this one is looking pretty great, but there's this feature on the texture that might bear repetition, that might be visible as we apply it to a surface, so let's see how we correct that. So what we can do is we can use the in-painting function to sort of isolate that blemish spot, and I'm going to use the exact same prompt, which, if I remember, was olive green concrete, and send it back. If I typoed, I didn't have a typo. Good on me. It's going to regenerate some stuff. All right, already these look great. There's a couple of blemishes here, but I kind of like this one. This one has character for me. Actually, this one is the best because it's got some nice richness in there. So now we're going to go to our PBR preview mode where we can see what this will actually look like. It's generating all the PBR layers for us. The height is way high right now, so I'm going to dial that back to something around that territory. Actually, I'm going to give it a specific value of 0.1, and let's see. Yeah, so you can see there's still some nice features here coming through in the concrete. I'm going to leave that smoothness. I'm going to dial it back just a tad. And then to apply it to the scene, I'm first going to drag it into my project folder, and then direct it to the scene, and voila. Just like that, we have got polished concrete vibes everywhere in this room. So far, so great. Liz, I think we need to do something more interesting with that back wall. Do you have any ideas?
Oh, I agree. Maybe let's brighten it up with like a yellow tile.
I like where your head's at. Okay, so let's go over here, and I'm going to give it a specific, we are all masters of this prompting game, or becoming masters. I'm going to say flat yellow as our base color, but now I'm going to do something different. So we want a repeated tiling pattern. And in order to do that, I can switch to an input image shape here and select from a bunch of beautiful predefined patterns. And I'm going to choose this hexagonal pattern, and now we're going to generate and see what we get. All right, of these, I'm thinking this one is the most usable. Liz, any standing out to you?
Oh, I think this time I agree with you. I think that's going to be the good choice.
It's good. I like when we're aligned.
Like when we agree.
I really do. Okay, so for this one, we're going to go to the edit mode, same routine. Let's go into our PBR preview. We're going to dial this down. I'm going to put this into the ballpark of 1. See a little bit. I want just a little bit of surface play. I want to catch some nice highlights in there. Dial that smoothness down just a tad. Same routine, drag it into my project view, and then over to the wall. And I would want to adjust that tiling a little bit, but I'm not going to bore you with that right now. Otherwise, we've shown you exactly how easy it is to generate textures directly in the Unity editor and apply them to the scenes. Liz, thank you. Back to you.
Thanks, Charles. And I'm thrilled to announce that Muse is available to all users through a single subscription. And while it's still in early access, you can experiment as much as you want without limits. And we'll continue to learn and make Muse work better for you. But instantly producing usable sprites, textures, and code snippets is just the start. To me, what's really cool about Muse isn't just what you can do today. Muse subscribers will also get priority access to new capabilities, like Animate, to set characters in motion without code. Behavior, which lets you use AI to set up character interactions. And Sketch. You can think of Sketch as providing a 3D canvas for rapid prototyping and team collaboration. And we're going to show you just how fast this comes together.
Okay, so using Muse Sketch, your team can collaborate in real time to prototype a zombie game using a powerful natural language interface. And it works in every language. So, teammates anywhere in the world can build interactive prototypes and scenes together in real time using a powerful and intuitive workflow. Using Muse Animate, you can generate humanoid animations for any Unity project using natural language to describe them. So getting a realistic zombie walk or even a backflip animation is easy, and now it's for everyone. So Muse AI capabilities allow your team to build gameplay and generate assets with remarkable ease and speed, and they're all integrated with the Unity editor to greatly accelerate your game development process in Unity. And here what we're showing with Muse Behavior, you can refine your gameplay and add elements that will excite and engage your players directly in the Unity editor using the same natural language paradigm to author these behaviors. Our idea with Muse is we want you to iterate more. We want you to try out more of your own ideas on your way to realizing your game vision, whatever that is. We think that AI is going to unlock all kinds of new ways for both creating and consuming interactive content. And now Manu is going to come on stage to show you another way that we're bringing these capabilities and helping you explore those capabilities in your game projects. Thank you, everybody.
Thanks, Charles. I was lucky to try some of these tools early through the AI beta program. And as an artist, I'm already having a lot of fun implementing them into my workflow, increasing both my productivity and creativity. But what if you want to build totally new experiences and features into your project? Sentis lets you bring AI data models into the Unity runtime to unlock new possibilities in your games. Think of it this way. Just like a physics engine is a tool that helps you bring your game world to life, a neural engine can help you solve complicated tasks or even create new functionality using AI models. Sentis reduces the complexity of bringing AI models into the Unity engine so you can supercharge your development with richer, more interactive gameplay features like speech and object recognition. You can take models from places like TensorFlow, PyTorch, Meta, OpenAI, or marketplaces like Keras or Hugging Face, and Sentis uses the Open Onyx file standard to bring them into the Unity runtime. This gives you real choices when it comes to the models that you want to run in your dev projects. But that's not all. Sentis can be run as a local inference, so these AI models can execute directly on the user's device. So it's fast, secure, and it's on any platform that's supported by the Unity runtime. And you even save money on server costs. That's already pretty awesome, right? But what does this actually look like in terms of real, usable features in your projects? Well, with Sentis, you can create a lifelike NPC and interactions that are infused with the flavor of your game world and writing style. And this saves you having to code dialog trees for hundreds of characters by hand, or building an expensive machine learning model that might add latency issues, or need some kind of cloud infrastructure element. When Sentis is running on a player's device, you can integrate models to support features like smart NPCs with enhanced dialogue capabilities. Let's see. I'm going to move on this side because I'm too tall for this stage.
Good evening. Welcome to the pulsing heart of Unova. Where are you headed?
To the police station, please.
Certainly. What's the reason for your visit?
It's official business.
Understood. Rumor has it there were some disturbances in the vicinity recently.
I'm aware, but I can't talk about it. It's confidential.
This internal demo uses multiple AI models to accept speech input and create a natural language response with a realistic voice powered by a partner replica. What this means is that now you can create living worlds where non-player characters are more interactive. And in this case, both dialogue and the gameplay quest evolved based on the interactions with NPCs. Just imagine the new kinds of gameplay you can create and that you can unlock now. Let's see another example. This one is unbelievable, and it was built by a high school student who was part of our Sentis beta program. It uses pose estimation model to determine the exercise movement leveraging the on-device camera, and it's showing muscle activation in real time in an augmented reality app for iPad. Next, I want to show you this VR demo. It's a meditation app called Trip, so it's not a demo. The developers are running an AI model locally on the headset motion sensor data called the IMU to track breath biometrics. And this assesses how the meditation content is affecting the user and adjusts the experience accordingly. Incredible, right? Trip already has this feature in beta, and the team plans to launch it in production early next year. One beta developer used Sentis in India to drastically improve ray tracing on mobile using an upscaling AI model. With something like this, you could implement path tracing features like light refraction and caustic area light in smaller projects with minimizing a hit to performance on the user's device. It's mind-blowing to see how you might use Sentis to tweak technical elements of your game and improve performance. Unity Sentis continues in open beta, so you can start tinkering right now to unlock new real-time interactions and experiences in your game ahead of the general release alongside Unity 6. By taking, thank you. By taking the Onyx standard and embedding it with the Unity runtime, you can leverage countless AI models or neural networks and run them on any platform or device that's supported by Unity. To learn more about that reach, Ryan's going to tell you how we're helping you bring your content to more players on more platforms.
Thanks, Manu. It'll be fascinating to see how this tech gets used to push the creative envelope as you start bringing different AI models into your games across platforms. And this reach is what I want to talk about next. So far today, we've shown how we can support you throughout the game development lifecycle. Now, let's see how we can help you get games into more players' hands. With Unity, you can take projects to over 20 platforms today. And for those of you who want it, we offer resources to help you distribute and monetize your games. Services like the Unity China publishing platform can help you tap into a massive market, help you reach more players, and realize greater value with localization, platform adaptation, and game publishing services to reach audiences in China. While Supersonic can increase your impact worldwide by helping you to scale your mobile game with publishing, testing, analytics, and more. We sat down with a solo dev, Gabriel Corrieu, who creates games as CNEX. He's the developer behind the hyper-casual hit Hide and Seek. He shared why harnessing Unity and Supersonic together helps him to stay on top.
I am Gabriel. I am the developer of Hide and Seek, the game that was published with Supersonic in 2020. The game engine of choice for creating the prototypes for the hyper-casual games. Naturally, it was Unity because of how flexible and how fast it is to make changes. Not only that, but Unity has a whole ecosystem built around it. The process of actually launching the game was a very smooth and awesome experience. I remember after launching the game, it became profitable from the very first day, and the game would just surface at the top of the charts. I was just super excited and refreshing every 5 minutes to see if it was still there. Being part of the Unity ecosystem is always one click away.
I just love hearing stories about how these tools enable you to succeed on your own terms. And that includes being able to take your game to players anywhere they're playing. We think you should be able to create your game once and then ship it anywhere and unlock performance across mobile, desktop, console, web, and XR devices. Look at Everguild, the studio that developed Warhammer 40,000, Warforged. That's the greatest effort to bring this franchise into a free-to-play digital card game. They used one code base for multiple platforms, cutting their engineering time for iOS and Android in half, while also saving them months on their port to PC, which you can check out now in early access. Now, sticking with mobile devices, we know that mobile web is important to you. We're optimizing support for web across mobile browsers, so you can feel good about shipping to millions more screens around the world. That's officially supported in Unity 6. We're also investing deeply in graphics and rendering with web GPU, so your games can be rendered in stunning detail without sacrificing performance. Now, beyond tech improvements, our deep industry partnerships can help boost your game's visibility. And today, I'm happy to announce a new partnership with Meta to bring Unity titles to instant games across Facebook and Messenger. This will be available in beta late next year. Let's shift gears now and look at XR and spatial computing. Something big is happening in the world of virtual, augmented, and mixed reality right now. The space is evolving quickly, and we're investing deeply to move with it. Made with Unity games make up to 50 to 60% of early titles in the latest XR platforms, like the Meta Quest 3 and PlayStation VR 2. And we're committed to making sure that we're ready to help you release on emergent platforms from day one. We're adding more ways to build mixed reality games and experiences for the Meta Quest 3 by officially launching AR Foundation for the Quest platform. So you can bring the real world into your mixed reality games. And you can use our templates right now to start building. Earlier this year, Unity's platform support for Apple Vision Pro was announced at WWDC. We've loved seeing your enthusiasm. People from over 145 countries registered interest to participate in the beta for visionOS. Now let's hear from someone who had a chance to explore this tech firsthand. Tommy Palm, the CEO and founder of Resolution Games. That's the studio behind Blastin', Bait, Angry Birds, VR, Isle of the Pigs, and several other made with Unity titles. Welcome, Tommy.
Thank you, Ryan. It's great to be here. At Resolution Games, we like to make our title available on whatever device player wants to use, which is why we worked so hard on bringing our award-winning dungeon crawler, Demio, to as many players as we could across PC, console, virtual reality, and even mixed reality. Unity has been a major factor in making crossplay between these platforms possible. We're thrilled to share that Demio is in active development on Apple Vision Pro for fully immersive and mixed reality gameplay, made possible by Unity's powerful support for visionOS. Unity's platform support and comprehensive tools for spatial computing makes it straightforward to leverage our experience using Unity and easily getting started with Apple Vision Pro. Unity's documentations, templates, tutorials, and samples help us implement features like hand tracking and spatial anchored content, so we can focus more on delivering a first-class experience to our players. We're thrilled to be one of the first customers in Unity's PolySpatial beta for visionOS, and couldn't be more pleased with the amount of support and engagement we received from the Unity and Apple team, answering questions, helping us understanding complex topics. We can't wait to have our players experience Demio on Apple Vision Pro early next year. Thank you. Back to you, Ryan.
Thanks, Tommy. It's great to hear that this has been such a positive and inspiring experience for you and your team. And that's why we're thrilled to share that support for the Unity visionOS beta is now available for all Unity Pro, Enterprise, and Industry subscribers, so you can begin to explore the latest tech. Expanding your game's reach has always been a cornerstone of our vision. So we make sure that you can take the Unity runtime to take your games from mobile, web, console, XR, and everywhere in between. We kicked off today's keynote talking about how game development is an ongoing process. And that's why we're working to ensure that we're delivering you a complete and reliable platform so you can build, ship, and run incredible games. We saw a lot of great stuff today, and you can read about all of it in our recap blog. The incredible features and stability of our most recent release, the 2022 LTS, and a preview of Unity 6, our next LTS version set to launch next year. We're really excited about this one. You can find out all about it in our roadmap session later today. We also announced release updates about several powerful solutions like Safe Voice and moderation to help you manage game toxicity, and Unity Cloud to enhance collaboration and asset management workflows. Plus, AI tools like Sentis and Muse to help power new modes of creativity and accelerate iteration. And that is just the start. But for now, I'd like to hand the mic over to Kelly.
Thanks, Ryan. So, that's our keynote. I hope you're as inspired as I am. We have some fantastic technical sessions lined up for you today on these topics and more. I'm hoping to connect with a lot of you here, but I'm only one person, so I want to make sure you're all aware of our Made with Unity program. This is where we partner with devs early in the game, yes, pun intended, to support you with development and co-marketing opportunities. And you can submit your game via our online portal to learn more. Now, we're going to end this keynote the same way we started it, celebrating all of you and your amazing work. Please put your hands together for the winners of the 15th Annual Unity Awards. Congratulations to all of our winners, and you can check out everyone listed on our website. And I also want to say that your trophies are on their way. So, I did say it was the end of the keynote, but before we completely wrap up, I have one more special guest to bring on stage. Please join me in welcoming Unity co-founder, David Helgelson.
Hey, thank you. Hey, it's so wonderful to be here with you in an actual physical space with, all of you. Well, there's also people watching online, actually. But anyway, and, this Unity journey has been so long and so arduous and so crazy. There's been so much blood, sweat, and tears spilt. We've had some really high highs and some low lows, by the way. The mission to democratize game development, is a long one and it's never over, obviously. We've done some very cool work, And I think we got to a really good place with the engine, and I'm really proud of that. When we did the first Unite conference, it was 2007, and we had 10 employees in the company, I think. But we still felt this urge to have a worldwide developer conference inspired by Apple, of course. And so we sold 32 tickets in San Francisco. And we couldn't pay the catering bills for several months after. But it was so great, because we kind of melded with the community, with the people actually using Unity, and when we're at our best when we're really kind of in unison with the community, and like when the boundaries between kind of inside the company and outside the company blur, and Unite is kind of the best of that. This ambition of ours, we've always been a very ambitious company. We always tried things that were like really hard, and sometimes failed. And it's almost like a curse and a blessing, I think. And this ambition kind of also drove us to kind of try things that maybe we shouldn't try, and we failed at some things. And it's been a tough year in many ways. What I'm really excited about now is that we're really trying to focus and like going back to core and really focus on the needs of you guys from performance, stability, workflows. And I hope that we can kind of show you that today. And of course, the proof's in the pudding. It's the next many years that we journey together that will show whether that works out. But I think the focus is there. I think we're really trying, and I'm just really happy to be with you. It's going to be a wonderful day, and I'm going to hopefully meet a lot of you. So thanks for joining us. Thanks for using Unity. Thanks for building really cool stuff, and enjoy the conference. Thank you.
welcome back from lunch, and welcome to the road ahead for game development with Unity, also known as the Unity Roadmap. Before we get started, here's our safe harbor statement. I'll give you a second to read it. It's just a legal statement explaining that you should still do your homework when choosing your technology. I'm Andrew, and I get to lead product management for the Unity engine. That's our editor and runtime. And I'm joined by an amazing team of speakers over here. We've got Stephen, James, Nadine, Laurent, and Danny. And together, we'd love to share with you what Unity is doing to ensure that you have a complete platform for building, shipping, and running great games. You'll hear how our new graphical capabilities and upgrades are going to make your games shine. We'll talk about what new platforms and enhancements are on the way, plus how to expand your audience with what's new for multiplayer support. We'll also share the latest from our AI initiative with several innovative tools to give you new powers to build worlds in ways that you maybe have not yet thought possible. And of course, the latest from our Wētā team on professional artistry solutions. But first, let's start with Unity 6. So this is what was formerly known as Unity 23 LTS. And we're proud to announce Unity 6. It's the next major version of the engine and editor coming in 2024. It's going to come back packed with a bunch of really critical developments that we're really excited for you to get your hands on. And it is that culmination of the last year's worth of releases and development that we've been doing. But why go back to a numbered versioning system? Well, honestly, it was driven by your feedback. Together, we think this is going to provide better clarity, more transparency, and just flexibility in how we release Unity. And honestly, it's just a little less confusing than the number thing, year number thing. So Unity 6, it's all about powering your ambition. So our commitment is always to put you and your needs at the forefront of what we do. So with Unity 6, we're starting with really boosting rendering performance, enabling your project to look the best on the lowest to the highest end of devices, and really making every pixel pretty with our new lighting tech. You saw some of that this morning. We're going to dig in even deeper here. With our multiplayer center, you can create, launch, and scale multiplayer games much more easily, and our cross-platform AI runtime really opens up new possibilities for you in the editor itself. And of course, we're always enriching our platform support and making continual productivity and quality of life enhancements across the editor. So, how does the release naming work? Just to give you some visibility on how that'll pan out. So the 23.2 tech stream was released today. Congratulations to everybody in the team. That's awesome. So please go download that if you haven't already. But right after this, we're going to start switching to that new name. You're going to see it start to roll out, of course, just in our versioning as we get out there across the hub, across docs. And that's going to be accompanied by interim releases through the next little while until we release Unity 6 later in 2024. Honestly, this is just how you're used to things being with the existing LTS cycle. And on that note, Unity 6 is being released under that same long-term support term set. So meaning you get the same commitment to reliability and quality just as with our LTSs. And the support and updates, as ever, will come subsequently after we ship that. And of course, you'll see platform updates in there and just that continued focus on support, reliability, and stability. So ultimately, our goal is to be even more agile than before, allow us to address what we hear from you, your needs, your requirements as they evolve, and ensure that you have all the tools you need to succeed. Speaking of which, I'd like to invite Stephen up to the stage here. Please welcome him to kick things off for us.
Thanks, Andrew. Hi, everyone. I am really excited to share our roadmap for rendering and visual effects. At Unity, we want to provide you with a scalable, extensible, and productive render pipeline so that you can use them to build best quality visuals on the broadest range of devices. So throughout our section of the roadmap, we'll show you some of the foundational changes we've made and new features we've put in that are coming to you with the next Unity release. So before we get started, with the roadmap, I wanted to share once again how you can learn more about what you can do with the 2022 LTS release that's available to you today. To demonstrate some of the features that we've built for the Universal Render Pipeline, or URP for short, you can use the new URP 3D sample project. This is especially useful for new users that are embarking on their URP and Unity journey. It contains 4 scenes, so you can download. They're each in a different art style and with varying rendering complexities and platform performance needs. It is a great way for you to get started. So download this project today and explore more. OK, now let's look to the future. As demonstrated in our keynote, one of our highlights of Unity 6 is the GPU resident drawer. It is designed to optimize your games and make your life easier without you needing to change your content. It's one of our ways to help you render more larger and more complex scenes without your needing to tweak them for optimizing content. So alongside this, we have our new GPU occlusion culling, which uses a GPU-driven approach to make sure that you aren't rendering things you can't see in the screen. As a result, for both URP and HDRP, and depending on your content, it can reduce CPU work dramatically. GPU resident drawer will be supported on a wide range of platforms, including high-end PC, mobile, and consoles. The next highlight we showcased was spatial temporal post-processing, or STP, our new state-of-the-art upscaler. STP is designed to help you deliver content across platforms and devices with varying levels of platform capabilities and screen resolutions. Frames are rendered faster, high-quality content can be scaled to more platforms, and no changes are needed to your content. STP should make it easier for you to achieve high target performance while maintaining your target quality. Another highlight of Unity 6 was adaptive probe volumes. APV enables a new way for you to build global illumination lighting. In previous releases, we provided a preview of this feature in HDRP only. With Unity 6, APV will be production ready in both URP and HDRP and comes with additional features. Let's take a closer look at this one. As well as simpler probe placement workflows and faster duration for light probe-based indirect lighting, you can now benefit from improved image quality and more control of optimizations for runtime performance based on your target platform. APV in URP enables you to choose between per vertex and per pixel quality so that you can run your content more performantly, even on low-powered devices. And having APV integrate seamlessly with atmospherics means that effects like volumetric fog in HDRP and VFX graph particles in URP and HDRP are now beautifully lit by indirect lighting. Plus, with our suite of streaming features for APV, light probe data can be streamed from disk to the CPU, from the CPU to the GPU, making this especially useful for larger scenes. And that's not all for APV. You can now also benefit from baking various lighting situations and blending between those at runtime. This can help you build more interesting lighting experiences for your target audience. And in the next major Unity release, we have also included the new sky occlusion feature. In HDRP, sky occlusion will use sky color dynamically. In URP, sky occlusion will use the sky color that you manually control through scripting or animation. Both can enable you to achieve lighting transitions as displayed in the examples here. OK, so this summarizes the features that we displayed in our keynote. Next, here are some additional features and improvements that you can leverage in both URP and HDRP. To start, we are thrilled to announce that Unity's GPU Light Mapper is now production ready since the 23.2 tech stream. Leveraging the processing power of the GPU, this light mapper gives an order of magnitude faster lighting data generation times as compared to the CPU light mapper. This now uses a new light baking backend for on-demand bakes, significantly simplifying the code base and making the results more predictable. This also means that we've been able to lower the min-spec GPU to 2 GB, making this more accessible to more creators. This release also features a new feature like the new API that you can use to move light propositions at runtime for procedurally generated content, and many quality of life improvements. You can learn more about these changes in the forum posts we've published during beta testing, and they're linked for you here. OK, now let's switch gears and talk about improvements we are delivering for our graph-based artist tools, starting with VFX Graph. We want you to build performant visual effects and get set up with our visual effects tools quickly and efficiently. That's why we've added a new profiling tool that provides you with feedback on memory footprint and performance for your VFX graph assets, making optimizations during development more easy. We've also added new VFX templates, enabling you to start from some commonly used VFX setup, as well as new sample scenes to assist you with your learning even more. For more seasoned VFX artists and developers, we've also added custom HLSL block. With this feature, you can create your own unique effects that might not yet be natively supported in Unity. This really extends the possibilities of VFX graph. For example, you can add custom effects like flocks through neighbor search, or you can read back from a buffer to trigger audio. Also for VFX graph, we continue to ensure that rendering features previously only available in HDRP can now also be leveraged in URP. It's now possible to customize and spawn decals with VFX graph in URP. Six-way lighting enables you to create more realistic-looking smoke effects beautifully integrated into your virtual environments. And in URP, VFX graph particles can now generate motion vectors, ready to be integrated with effects like temporal anti-aliasing and motion blur. Last but not least, for VFX graph, we're taking HDRP capabilities even further than in previous releases. The effects can be rendered in ray tracing passes, where you can use them, for example, in ray trace reflections. And volumetric fog output makes it possible to inject VFX graph particles into volumetric fog to generate clouds, smoke, fire effects, and make volumetric fog even more dynamic. Let's move on to our next graph-based authoring tool, Shader Graph. So in Unity 6, Shader Graph enhances your productivity with quality of life improvements like faster undo-redo, hotkeys, and a simplified toolbar. And to help with optimizations for shaders, we've introduced a new heat map color mode. This highlights the most GPU-intensive nodes that you have in your graph network, so you can easily identify those and optimize them. We've also included node references, feature examples, and production-ready assets to help you streamline your creation experience even more. You can now also create dynamic UI backgrounds and shapes using procedural patterns and functions using dynamic UI content. So that's it for our graph-based tools. And next up are improvements to graphics device, drivers, and low-level APIs that are available for both URP and HDRP, starting with high dynamic range displays. These displays are becoming more and more available and produce images with higher peak brightness and wider color gamut, and they achieve higher contrast and more intense color saturation. We want to make sure that you can leverage these displays. As of Unity 6 in Unity Editor and Standalone Player, we are now providing you with cross-platform support for HDR output, including mobile, along with full compatibility for both URP and HDRP. And once you've implemented HDR into your project, we make it easy for you to learn how to incorporate HDR calibration menus using the new HDR calibration template. We use this to avoid common challenges like under and overexposure and ensuring that text on screen remains legible. We are also excited to announce that the ray tracing API is now officially production ready and is supported on a wide range on Windows, Xbox Series X, S, and PlayStation 5, and is accessible by both URP and HDRP. That's right. Out of the box, you can utilize this API with a collection of leading-edge ray tracing effects for your projects in HDRP. In Unity 6, we've also added the ability to issue hardware-accelerated ray queries through inline ray tracing and shaders. This unlocks new and exciting possibilities for custom effect authoring, such as custom ray traced shadows. Additionally, we've implemented acceleration structure optimizations to help reduce memory usage when ray tracing complex and larger scenes. Let's move on to additional ways we're improving performance, starting with the new threading mode, Split Graphics Jobs. Split Graphics Jobs significantly improves CPU multi-threading performance by reducing unnecessary synchronization between the main thread and native graphics jobs threads. The performance gains, they increase based on the amount of draw calls that are submitted in your frame, and this new threading mode is supported on Windows, Xbox, PlayStation platforms, and the Unity Editor now also supports graphics jobs on Windows platforms, which improves the scene and play mode rendering performance. So this wraps up the features you can leverage in both render pipelines. Next, let's focus on performance improvements we've made for the universal render pipeline. Our primary focus this year has been to enhance the core of URP and its API. One major highlight of this is improving the foundation of URP with Render Graph. Render Graph provides a great foundation for GPU performance optimization and is optimized by default for tile-based rendering, which is commonly used on for mobile devices. For those of you who love to push the boundaries of URP or offer extensions on the asset store, the Render Graph API integration offers improved extensibility and easier access to rendering data like the gbuffer. Now, even if you're not dealing with all of the APIs, these changes still bring you benefits, as they enhance memory bandwidth, resource management, and optimize built-in passes. Also in URP, in Unity 6, we're introducing VR foveated rendering support for Oculus XR, PSVR 2, and OpenXR. Foveated rendering concentrates quality on where the eye is focused while reducing quality in the periphery. This improves GPU performance and enables you to achieve higher frame rate with high quality visuals in VR. Our solution also introduces gaze foveated rendering, which applies this technique based on where the user is looking inside VR. The result is that you can provide a smoother VR experience while maintaining high visual fidelity. OK, we're getting close to the end of our update for rendering visual effects. I'll close out by moving on to new features you can leverage with the high-definition render pipeline. For the high-definition render pipeline, we want to be able to ensure that you can create beautiful environments, and that includes maximizing visual quality for sky and for water. For water rendering in Unity 6, we included many enhancements. For example, you can build more realistic-looking water by including currents in rivers and seas. These are controlled through flow maps. For floating objects on the water, you can also use generate foam using the foam generator, and rendering can be to make even more realistic with a custom waterline and much improved compatibility with transparency in clouds. For you to get started more easily with our water features, we've also included samples for common use cases like oceans, rivers, and pools. Next in HDLP, we want to help you expand on your environment lighting. You can now include a new night sky with stars, planets for your time of day scenarios, and we have improved visual fidelity for the physical sky, which can now include atmospheric scattering and an ozone layer simulation. The final highlight we want to share with you are the enhancements we've made to HDLP character rendering. Not so long ago, we unveiled Enemies. This cinematic showcased Unity's latest advancements for rendering high-quality digital humans. With Unity 6, we're pleased to announce that character rendering features demonstrated in the Enemies will now be made available to you in HDLP. For beautiful hash rate rendering, this includes the line rasterizer with improved lighting, performance, and anti-aliasing. And for improved skin shading, we've added the dual lobe option to more accurately simulate the intricacies of a character's skin, making this especially useful for character close-ups. We are really excited to see what you'll create with these new features coming to rendering and visual effects in Unity 6. To find out more, here are some deeper dive talks that are happening later today. We have a session that focuses on how to achieve high visual fidelity in HDLP, and we have a session that shows you how to accelerate your multi-platform development with the latest for URP. On that note, I'll hand over to James, who'll be talking you through how to maximize your platform reach.
Thanks, Stephen. Hi, everyone. My name's James Stone. I lead product management for our core platforms here at Unity. And today, I'm going to cover what we're working on to improve our platform support. Unity now supports 20 platforms, and that list continues to grow. And our focus is to help you reach your players wherever they are. We work to make sure that you can ship across all major platforms, knowing that the performance and stability will be there. And we want to help you reduce the cost of supporting as many platforms as much as we can. So let's check out what's coming. And let's start with the roadmap for XR. Now, I'm sure if any of you watched the Apple Keynote, you would have been as excited as we were to see Apple Vision Pro announced. And Unity, through our collaboration with Apple, have built support for this incredibly exciting new spatial computing platform. In fact, tens of thousands of you have been extremely eager to get your hands on these tools for visionOS. So, starting today, I'm extremely excited to announce that we are expanding the beta to all pro, enterprise, and industry customers. And if you want to join in, please visit unity.com/spatial. Beta users can access initial platform support for building mixed reality apps enabled by Unity's newly developed PolySpatial technology. And later in the year, we'll bring even more advanced features for mixed reality development, including shader graph, particle system, and improvements to iteration and debugging tools. This is an amazing opportunity for all XR developers to be there right at the start of this new mixed reality platform. And we at Unity are proud to once again to ensure that the latest platform innovations are ready for you on day one. In addition to powerful tools for creating virtual reality games, we're excited to officially launch AR Foundation for the Quest 3, including features such as pass-through video, plane detection, occlusion, and our interaction toolkit. You can get started with your project today by downloading the virtual or mixed reality templates in the Unity Hub. I hope you were able to attend our deep dive session earlier today on how to elevate your mixed reality with Presence Platform and MetaQuest 3, and if not, please check out the recording after the event. Now, integrating real-world elements into your game is a core part of mixed reality. And we're making it even easier with these major highlights coming to AR Foundation and OpenXR next year. Spatial anchors lay the foundation for creating compelling mixed reality games by allowing you to precisely align virtual objects with specific locations in the real world. Many of you have been asking how we will expand on our existing support for anchors. So, starting next year, AR Foundation will support persistent, shared, and cloud anchors for your reality games. We are also introducing composition layers to give you flexibility in how digital content is rendered in a headset. From rendering UI more clearly to adjusting depth and additional projection layers, we're giving you more control so you can enhance the quality of your XR experiences. Furthermore, we're enhancing the way that environment data helps you understand major elements in a player's space. For example, we're adding plane tracking and mesh data to new platforms in AR Foundation so you can create more compelling and immersive gameplay. And finally, we're always looking for ways to speed up your development process. So coming to Unity 6 is our new cross-platform input framework, which will help you build natural input methods once that will work across many XR devices. Plus, advanced features are coming very soon which will allow you to create and detect your own custom hand gestures and ensure that reliable detection is there with debugging tools. With more devices supporting hand tracking, we are always thinking of new ways to improve interaction, and you can expect to hear more about this next year. You can quickly get started with creating XR experiences today with one of our templates for augmented, virtual, or mixed reality. And soon, you'll be able to get started creating social games with our new multiplayer template releasing next year. The world of XR and mixed reality is moving fast, but Unity's deep commitment to our platform support means you're ready to take the content to these new platforms on day one. So let's take a look at another platform that we've been making some major improvements to. Now, I know many of you have been eagerly awaiting some news on what we've been doing with web platforms. Well, today I'm excited to tell you that Unity now supports mobile browsers, starting from Unity 6. I know, right? It's cool. You will now be able to run your Unity games anywhere the web exists, including mobile browsers themselves. You can now run your Unity titles embedded in a web view inside native apps, or use a progressive web app template to make your games behave as a native app along with its own shortcuts. But that's not all. Through our strategic partnership with Google, Web GPU is coming in early access next year to Unity 6. You will now be able to leverage compute rendering techniques like compute shaders, GPU skinning, VFX graph, along with even more GPU rendering techniques currently in development. So players can immerse themselves in complex scenes with stunning details. And you'll hear more about this in our web deep dive session later today. And finally, as you may have heard in the Unity keynote, we have indeed partnered with Meta to build support for their instant game platforms. And here, users can find and play games instantly on Facebook and inside Messenger conversations. And with an audience of gamers in the hundreds of millions, this is a fantastic new opportunity for Unity developers to participate in. And the web has always been one of Unity's most popular platforms, and I really look forward to seeing what amazing experiences that you all bring to this fast-evolving ecosystem. And speaking of ecosystems, I'd like to take a little bit more time to talk about the exciting news coming from our partnership with Microsoft. For 2023.1, Unity delivered support for ARM-based Windows devices, enabling you to bring your titles to this new hardware platform and achieve rock-solid performance and stability natively on ARM64 processors. Well, to build on that, we're excited to announce that native Unity editor support for ARM-based Windows devices is coming in Unity 6. This means you can now work on your Unity games on even more Windows devices, taking advantage of the performance and the flexibility that ARM-powered devices can offer. But it's not just about platform support. Our partnership with Microsoft also focuses on your success. And with that in mind, you'll be able to develop and build Win32 games using the Microsoft Game Development Kit, or GDK. The Microsoft GDK contains the common tools, libraries, and documentation needed to build Windows standalone games, including user management, achievements, Xbox Network, and other Windows-specific tools. We also include options to edit and your build configurations through scripting and build automations. So, let's take a look at now what we're working on in the world of Android. We know how important it is to you that not only do you want your games to install quickly, but they also perform well across a multitude of Android devices. Well, Unity 6 brings a couple of new features to Android. The first is support for Play Asset Delivery with the new Addressables Android package. You can use a new or existing addressable setup to benefit from Play Asset Delivery's dynamic delivery options. And when you combine this with texture compression target formatting, your players get textures customized for their devices at a much smaller install size. The second improvement is the addition of a new application point, Game Activity, powered by the Android Game Development Kit. This new system brings a number of new benefits, including improved threading support for lifecycle, input, and keyboard events, enhanced updatability outside of engine releases, and through the use of Android X, and access to the Unity X Android bridge. I said it without stumbling. That's a hard sentence. This brings you further customization over events such as events like pause and resume on the phone. But that's not all. We've improved real-time memory feedback for Android by integrating it with Google's Memory Advice API. You can now get real-time signals on the level of memory used from a healthy state to when you're approaching a limit or to when you've reached a critical state. And this can help you know when to make real-time adaptations within your project so that your users have an optimal experience on their device. Or you could even send it to your analytics for performance purposes. So coming next year to Unity 6, we've also introduced support for Android's predictive back gesture, so your users can avoid unintended quits from your application by previewing that it's about to close. And last but not least, well, sometimes things just do go wrong, and a game can close unexpectedly. Well, you can now integrate a host of new C# APIs providing access to your game's exit reasons. These insights will allow you to help fine-tune user messaging in case of crashes, send to your analytics, or even adapt how your game launches. So we've taken a look at the improvements we're making in the Android space, so now let's take a look at some improvements we're bringing to our console developers. For console developers, we've made some major improvements to iteration speed across all of our platforms. But before I dive into that, let's talk about the launch of PlayStation VR 2. So earlier this year, we worked in partnership with Sony to successfully bring support for PlayStation VR 2 on day one. And our developers saw great success with Unity in the launch window, with over 50% of titles being made with Unity. And this is particularly due to our XR stack, which makes it easy for you to develop a single project with the XR Toolkit and apply that across all of our XR platforms. We've also done a lot of work around optimizations for PlayStation 5 and foveated rendering for PlayStation VR 2, allowing you to squeeze significant performance out of your title with even a single click. And you can look forward to additional improvements coming to the PlayStation VR 2 platform with HDR support and in URP and HDRP coming in Unity 6. So let's also talk about our improvements to iteration speeds. The Unity incremental build pipeline allows you to iterate more quickly in between builds. And once a scene has been built, subsequent builds will focus only on the delta, meaning that your build times drastically reduce in most situations. And you can see from the graphic on screen that when we tested this with the boat attack project, build times have dropped almost 50% in Unity 6 versus 2021 LTS after you've changed the script. And if you build that scene again without any script changes, it dropped from 40 seconds to just over 5. And that's going to bring huge improvements and significant benefits to your iteration speeds during development. And this feature is now fully supported across all of our console platforms. So, finally, let's move on to some updates that we're doing to our core platform support. With Unity 6, we are introducing a number of quality of life changes and a new optional workflow for configuring your builds and targeting new platforms. And let's first talk about some updates to the build window. Today, we know a lot of you rely on build scripts to customize the way that builds are managed in the editor. And this is mostly because a lot of our build settings are global to the project, and they can't be changed per build. Well, our new build profile system is the first in a series of updates designed to address this common feedback. You can now have multiple profiles for a single build target. Perhaps you want many different configurations for Android. Well, now you can do that. Perhaps you want a build profile for your vertical slice, one for your demo, one for the final build, and each one containing different settings, different scene lists, and you can do that too now. And it will make managing your builds so much easier and offer you a higher degree of flexibility than ever before. And this is just the first iteration in a number of planned changes to greatly enhance your build workflows. And it's not just the build window. We're also enhancing platform discovery inside the editor as well. And the new platform browser is a place where you can discover all the platforms that Unity supports and get information on how to deploy to them, get documentation relevant to that platform, and even how to apply for closed platforms. And when you add a build profile from this new window, we will ensure that all mandatory packages and settings are correctly configured and installed for that platform, getting you up and running even faster than before. And these are just the first set of a number of planned improvements to enable faster cross-platform development, so you can look forward to more news on this next year. So thank you all for listening to the exciting updates we have across our platform ecosystem. We do have some deeper dive talks today happening, and I urge you to go and check them out. But for now, I'm going to hand over to Laurent, who will be talking you through the latest innovations in multiplayer.
Thank you, James. It's a real pleasure to be with you in person and to hear about all the crazy ideas you're putting into your games. My name is Lauren. I'm in charge of product teams for Dots and multiplayer. Unity has a unique multiplayer offering: engine, support, consulting, services, spanning from fast creation to launching everywhere and scaling with success. Unity Engine has evolved its set of out-of-the-box solution rapidly this year with Unity 2022 LTS. Casual cooperative games like the amazing Ship of Fools from Fika Productions can be developed quickly with simple editor netcode solutions and cost-efficient relay services. More ambitious competitive titles, such as Istera from Sticky Ox Studio, can now leverage the new high-performance editor netcode solutions and grow with success on the Unity game server hosting scalable infrastructure. And of course, Unity Engine is always extensible, and the low-level networking transport package used by our engine solutions can be leveraged for your own netcode implementation. This is how TurboGolf Racing achieved their bespoke netcode gameplay. Unity multiplayer services offer a range of dedicated services tailored to game developers to help you improve your player experience. Earlier this year, we introduced A/B testing for Matchmaker, allowing you to efficiently test and optimize matchmaking rules without disrupting game operations. Additionally, Matchmaker now supports leaderboard and cloud save integrations. From a hosting perspective, Multiplay partnered with Valve to offer Valve Steam Datagram Relay, SDR, making Unity the first game server hosting provider to provide DDoS capabilities. Valve SDR not only protects against DDoS attacks by obscuring IP addresses, but also optimizes network path in real time to reduce latency for players improving the overall multiplayer game experience. We also made improvements to our community solutions. The latest Vivox, a Unity SDK, simplifies the process of adding voice and text chat to Unity games, reducing necessary code by a factor of 30x. The new Unity audio source for Vivox enhances the immersive experience, particularly beneficial for VR developers. We also introduced safety tools in open beta, which you will all hear more about later in later sessions. Together, all those solutions offer an end-to-end communication and safety platform to ensure you build inclusive and engaged communities. And we are committed to continue our investment in multiplayer game, and we want to unveil some of the solutions being built. So let's start with how we plan to make the multiplayer game creation simpler. Unity has many solutions to help with a variety of multiplayer game needs. We are working at a series of templates to get you started, but we also understand you often have to navigate technical choices later when it is the time to introduce multiplayer concepts to your project. To help with this situation, we are working on a central location in the editor, codenamed Multiplayer Center, where you can play with parameters of your multiplayer goals and see what are the recommended tools, services, educational material relevant to your project at this point. You can add some of those directly to your project and start experimenting with those multiplayer capabilities immediately. Once you have a working gameplay, the very next step is to try it out with multiple clients to get a feel of the experience using separated processes. This is what multiplayer play mode will deliver. It enables multiple editor instances of clients along with server to be opened simultaneously on the same device using the same source asset on disk, providing a more efficient and quick development cycle of multiplayer games. You can see it working with our casual co-op boss room sample. It's true that it really, really helps with development. The next step is usually to involve another player. And in a casual co-op scenario, that will often be in a client authoritative multiplayer gameplay coupled with a relay server. To speed things up, we are integrating Unity Gaming Services Relay so you can simply create a session and get somebody else to join your play mode. Your multiplayer game might require a server authoritative model to prevent cheating, for example, when there is some competition involved. While you could use multiplayer play mode with any netcode stack, here is an example based on Dots for an action competition game using the latest Megacity showcase, Megacity Metro we unveiled a little bit earlier today. In such a scenario, multiplayer play mode will support the local and remote deployment of dedicated server to keep your iteration loop as short as possible, even when you have a complex topology network. We've delivered in 2021 LTS a dedicated server build target, allowing you to create both the client and server from a single project, reducing significantly the development and iteration time. We're adding additional content selection features that will help you to go one step further in that process without custom scripts and help you make the server as lean as possible with options to strip out the client parts of your project. And when you need to introduce a cloud infrastructure, sometimes that would make your iteration loop for your dedicated server can become more difficult and slow to iterate. This is why we have taken steps to automate the upload of your build to game server hosting solution in Unity Gaming Services, allowing you to mix and match automatic creation of client and server and run deployment scenario faster and save you additional integration steps. So, getting your gameplay together is only one part of the challenge. You also need to get to market, and we want to ensure you have the best opportunities to do so. All the multiplayer gameplay solutions, the netcodes coming with a Unity engine, are based on the transport package. This package provides a robust, low-level networking layer you can leverage to build your own customized netcode for specific game needs. Transport now supports Unity Web, which means your solution can ship to all platforms. Of course, multiplayer play mode, dedicated server workflows can be used with your custom solutions. Building a multiplayer game often requires to integrate product and services together with thousands of lines of code. With our upcoming multiplayer services SDK, we are massively simplifying the integration and dependency management while offering a new way to interact with our services. And when you want to build rich multiplayer experiences, you might sometimes feel slowed by the complexity and high operational costs. We are introducing a new network topology solution called Distributed Authority to enable you to distribute simulation workload across clients, providing a scalable cloud backend coordinated by the highly optimized cloud state service. With such a solution, you can build large-scale multiplayer titles with lower operational costs, engineering efforts, and latency, opening up new possibilities for your multiplayer development. Managing the growth of a successful multiplayer game can be challenging and risky. Unity services are proven at large scale through powering AAA-grade productions that constantly requires us to push the limits. Here are some of the new capabilities coming to our services. In the world of multiplayer games, maintaining fair competition is crucial to keep players engaged. However, you often face difficulties when it comes to establishing a skill system of your own. Our skill-based matchmaker will eliminate the need for you to build a skill system from scratch. Through this feature, you can effortlessly compute player skill scores using various metrics such as wins, loadout, or in-game achievements. The skill-based matchmaker can be easily configured to suit the specific requirements of each game, ensuring a level playing field for all players. This fosters a genuinely fair competitive environment that boosts player retention and engagement. You also want to have better observability to track things that are happening to the matches created by the matchmaker, so you can see trends and catch issues earlier for debugging. Session Details offers enhanced observability into the matchmaker by providing you with match-level details. You can track major events that occur throughout the lifespan of each match, such as the specific matchmaking rules that have been applied to a match, the joining sequences of individual players, and backfill updates. With match-level observability, you can identify trends, detect and resolve issues faster, reducing time to iterate the matchmaker system. Protecting players and teams from harmful content is an important part of our mission. Next year, Safe Voice evolves by fusing semantic and acoustic analysis for sharper insights. Limiting the need for human moderators to review the evidence, we help increase the productivity and morale of moderation teams. Simultaneously, we're launching a revolutionary context analysis for text, taking the complete context of the conversation for analysis. Together, Safe Voice and Safe Text fortify our platform safety, empowering real-time positive play reinforcements for thriving communities. It is not just about curbing the negative, it's about cultivating the positive game after game. To get deeper into the multiplayer topic, please come back to main stage later today with 2 sessions to explore getting started with multiplayer game development and AI-driven solutions for toxicity management. This is a perfect segue to our next section, Unity AI.
Thanks, Laurent. Hi, everyone. My name is Nadine, and I'm the program manager leading our AI portfolio. How excited is everyone about Sentis and Muse? Great. That makes for a really great presentation. All right. Earlier, you've learned Sentis is our neural engine that allows you to import and run AI models in the Unity runtime. So let's recap. Sentis has been in beta since this past June and is ready for you to start using today. Sentis makes it easy to fuse AI innovation with your game development in the runtime and unlock new experiences that traditional code can't deliver. With a single implementation of your AI model, Sentis automatically optimizes it for all Unity runtime platforms, so you can create once and ship anywhere. With Sentis, running AI models locally on end-user devices enables the fastest inference time without network latency, avoids server inference costs, and reduces the burden of sending sensitive data to the cloud. As we look ahead into 2024, we will focus on a few exciting improvements. Sentence will leverage NPUs to speed up model inference and offload work from the CPU and GPU. We will also make it easier to interpret your AI model in code by adding a graph editor that allows for intuitive model visualization and layer and optimization edits. Lastly, there are cases where it's preferable to host your AI model on a cloud server, such as with large language models that are very large on disk. For these cases, you'll be able to use the Sentence HTTP wrapper for the API calls without changing the C# code, keeping the local and cloud inference inputs and outputs consistent to work with. While Sentence helps enable AI-powered game experiences for our creators, Muse offers a suite of capabilities that help simplify and accelerate game creation. As we've just announced, we've officially launched our Muse subscription. As a Muse subscriber, you'll have early access to texture, sprite, and chat, and access to our alpha programs for behavior, animate, and sketch. During the early access period, we are giving you unlimited freedom to experiment as much as you want. We believe through your experimentation, you can help us learn how to make Muse an ecosystem of capabilities that creators will find easy to use. Now let's dive a bit deeper into each capability. Chat is a web interface trained on Unity's own data to solve problems, answer Unity questions, and generate usable code. Sprite allows you to create 2D art trained by your own and altered through prompts directly in the editor. Texture is a natural language prompt used to create high-quality PBR textures fast. Behavior helps set up character interactions through natural language, saving time in the editor. Animate can bring your human-like characters to life through just a few prompts, and Sketch helps you rapidly mock up scenes through natural language prompts. Through our Muse beta program, we've received tons of your feedback. I mean, you guys did not hold back on your feedback at all. But because of it, we've learned a lot. Currently, chat allows you to find resources and generate code using natural language. In 2024, we'll be extending the reach and presence of chat to allow you to do more with natural language. With chat, we are meeting our developers where they are. We've also learned through our beta program the importance to further improve our responsibly sourced model to ensure we are helping you achieve game-ready, high-quality outputs. And we recognize artistic control is a critical user need. As a creator, your experience should be simple and intuitive, and your workflows should feel seamless. For this reason, we will add more customization features and make the AI work for you. Now, let's go deeper into what's coming in 2024 via our alpha programs. As mentioned, Muse subscribers will get priority access to our latest capabilities, behavior, animate, and sketch. With behavior, you will finally have the ability to create and manage behavior trees using natural language input without third-party tools. Yes, incredible. Simply describe the desired AI behavior using text prompts and let behavior transform textual descriptions into behavior trees and C# actions. With Animate, we are giving you the power to generate and customize 3D animations in just minutes, all while making it easy to export your creations into Unity and other 3D software. With Sketch, we're taking the guesswork out of playtesting and giving creators the ability to ideate and conceptualize. Sketch empowers teams to collaborate, prototype, and iterate in real-time 3D with no coding required and fully integrated with the Unity ecosystem. So, I know you're already thinking, what about my data? While data sharing helps improve our models and your experience, Unity is committed to responsible data sharing and with Muse, we're giving our creators an easy way to opt in or opt out to sharing your data. As you can see, with Muse, we are meeting our creators where you are, and we will continue to grow our ecosystem with you. To learn more, although our 2 Sentis breakout sessions just wrapped up, we will have a Muse breakout session at 3:30 p.m. where we'll take a deeper dive into building with Sprite and Texture. And you can also get hands-on with Sentis and Muse at our demo station located in the hub. Thank you. I'm handing it off to Danny.
Thanks, Nadine. My name is Danny Oakes, and I'm a product manager for Unity Wētā Tools, focusing on environment workflows. And I'm very excited to be here at Unite to share more about the art tools we're building and give you a glimpse of the roadmap for Wētā Tools. So as Wētā Tools, we're delivering a collection of workflows for creating high-fidelity content that is both performant and interoperable with all major 3D engines and DCC tools. Our goal isn't to empower creators where they work, but we really want to empower creators where they work, especially inside of Unity. And today we're going to be focusing on 2 critical creative workflows. First, character creation with Ziva, including a newly released Ziva Real-Time for Unity, bringing data-light, film-quality assets into real-time. And second, we'll be talking about what's next for our environment tools with SpeedTree and the next evolution of vegetation in the Unity engine. There it is. Let's get started by diving into Ziva. Ziva is a suite of tools for character creation that is literally more than just skin deep. With Ziva VFX, you can create compelling movement for any type of character by accurately simulating muscles, tissue, skin, or even cloth. This deep level of simulation results in unmatched believability when characters, humans, animals, or honestly anything else come to life in your movies or games. Ziva Real-Time is our middleware implementation. It brings these characters into the game engines. With a hyper-efficient ZRT format, you can then translate those character-specific behaviors and deformations to real-time models without compromising memory budgets. This powerful real-time character pipeline is available today for the Unity engine. This workflow is made up of 2 components. First, there's the Ziva Real-Time Trainer, which is used to translate simulations to a format usable in real time, and is completely indifferent to the origin of data that it can ingest. And this is really important. Whether created with Ziva VFX or any other tool, users can use the Ziva Real-Time Trainer to create ZRT files. Second, these ZRT files are then ingested into the real-time player, which is a runtime package that enables these files to play back in the Unity engine, and is again available today as a downloadable package for Unity, and will be included in the next LTS release. So what's next? Integrating Ziva into the Unity engine is really just the beginning. Through the next year, we're continuing to invest in our real-time pipeline by introducing topology deformation transfers for enhanced LED support, GPU optimizations for better performance in Unity, and enhanced quasi-static clothing support for real-time deformations of clothing on your characters. And as always, we're continuing to refine the user experience for a real-time trainer to make it a delight to use. We're also excited to be bringing our hair and fur authoring tool, Wig, to users in Q1 2024. Launching as a USD-based Maya plugin, Wig brings incredibly intuitive grooming workflows with a focus on art destruction and non-destructive ways to work. Wig ensures fidelity to the creator's vision that is represented in the final product. We're really excited to share more about this in our breakout session today at 4 o'clock, so please come by, and also come by the demo booth where you can see it in action. All right, let's dive into what we're going with our environment tools. This year, we released SpeedTree 9.4 and 9.5, which included an incredible amount of new features for creators. Honestly, I've been with SpeedTree for almost a decade now, and this is the most features I've seen released in a single year, and it's been exciting to watch. It's made it easier to build both stylized and realistic vegetation without having to break your flow or switch to another tool. It's now easier to create and edit leaf meshes using frond sections to create highly detailed leaves with non-destructive workflows. We've added new tools, projectors, which allow you to raycast mushrooms, details, or even snow onto your creations. We've also responded to creators' feedback and implemented an improved cutout editor that makes it easier to create leaves from existing atlases, whether using texture atlases made with SpeedTree or imported from other applications. And we're not slowing down. Our developers are hard at work right now getting ready for some incredible releases next year. I'm excited to be able to give you a quick look at some of the new features coming in 2024. SpeedTree 10 is the first release of the modeler that really illustrates the impact that being part of Wētā Tools has had on our creation. As we integrate workflows from our friends over at Wētā Digital, we have new tools that will help you create vines that can be draped across branches. You can shape and trim whole trees with new tools where you can just, with one click, just create a circle, create any shape you want. And we've had a complete overhaul of the speed tree UX to make it easier to find what you're looking for. But we've also been laying a foundation on, some new tools for speed tree's future. So over the entirety of speed tree's development, we've been focused on how to bridge the worlds of simulation and art direction control. Rules is a new workflow within SpeedTree that allows you to control multiple properties at once. This means you can change things like the spine length of the trunk or the branch radius of one of your upper branches across single or multiple generators. This allows creators to build new tools for growing assets within SpeedTree, whether that's simulating life stages of a tree, the environment that the tree lives in, changing the shape from a forest tree to a field tree, or just creating fun shortcuts to fine-tune the shape and structure. All of these can be controlled and edited inside of the SpeedTree modeler with simple Lua scripts. Now, the natural next step for rules would be to create a whole library of smart assets and have these rules pre-applied to them from the start. So that's what we did. Our artists are building rules into the SpeedTree library, allowing you to quickly edit all of our trees with a few intuitive controls. On top of this, the all-new library of assets will come with a new standalone tool to quickly download the SpeedTree library so that you can make changes with a 3D viewer and rules editor, open it up directly inside of SpeedTree for more complex work, or just send it directly into Unity or any other DCC with the same export options that you have inside the SpeedTree modeler. We're really excited to see what artists are going to do with these new tools, and they'll be available early next year. But we're also really excited about what these opportunities open up for the Unity engine. As part of Unity, we're helping across all of our teams to make Unity a better place to build environments. Unity 6 includes a host of improvements for world building and environment art, which will make working with speed trees a much more natural fit. This is on top of a rebuilt speed tree integration that improves wind performance with a new GPU-driven wind. But with the addition of rules, we have an opportunity to create something new inside of Unity. So what we're doing is we're bringing SpeedTree rules into the Unity editor. We're going to allow you to open up a procedural SpeedTree directly inside the SpeedTree editor and then power it to change however you want. So you can control these rules by environment textures. You can control them by sliders inside the Unity editor. And this is all powered by a new tool called the Pipeline SDK, which is the backbone of the SpeedTree procedural engine. Once you're able to edit these trees inside the Unity editor, you can drive whole forests with just a few assets. The possibilities of this integration are endless when combined with the existing tools inside of Unity. So again, be sure to join us for a breakout session today at 4 o'clock for more information about these workflows coming from both characters and environments. And here's Andrew to close us out. Thanks, everyone.
Awesome, 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 amazing stuff. I love to see all that integration back into the editor. But look, we're really, really focused on enabling Unity 6 features and making sure they're rock solid, stable, stable, stable. Before we go, we wanted to tease your creative taste buds, if you will, for what's ahead after Unity 6. Given it's been our #1 piece of feedback in the last few years, it won't surprise any of you that iteration speed is going to see significant improvements. So what are we doing? Well, along with the new content pipeline, which will push many operations to the background, a lot of things will become non-blocking, you are going to see a lot less progress bars. That's our commitment there. Connected with this, of course, is the goal of iteration speed and just core performance is, of course, where we're taking our use of .NET. So at GDC this year, we announced that we are moving to core CLR for our Unity C# runtime. That work is absolutely on track. We're really, really happy with how that's going. And we'll be upgrading Unity to .NET 7, which in our benchmarks internally shows at least 2 to 10 times speed up in some of those areas of raw performance. And of course, allows us to stay current with the whole .NET ecosystem, the latest C# and so on and so forth. Finally, one of the big highlights certainly for this year for me was getting my hands on Dots 1.0 as part of the 22 LTS. And we're absolutely committed to really driving and integrating Dots further into the core engine. and really evolving the scalability of the game object architecture that we have. So there's a lot of really, really cool stuff there. Rejoin us at GDC, where we'll be going into depth in all these areas in much more detail. But look, first of all, thank you to all the speakers for an amazing session today. Thank you to you for your attention. And we'll leave it there, everybody. Thank you.
Thank you for joining us today for our talk on instantly bringing Unity games to players on the web. We have some new web features you can try today, as well as some really exciting things to share that are coming in the near future. I'm Ben Craven, a senior technical product manager at Unity, looking after web platform. This is Anthony Bowker, a senior engineering manager on, you guessed it, web platform. So first, I want to talk a little bit about where Unity has been and where we're going from here with the web. As some of you may know, Unity has quite a bit of history with web runtimes. In 2013, the Unity web player debuted as a plugin for web browsers. This solution was short-lived, as it was deprecated 2 years later in 2015. Then, we adopted WebGL to run games directly in the browser with asm.js. Unity was there at the beginning of the WebAssembly design process, and we've been evolving alongside WASM ever since. This brings near-native performance of the Unity engine to the web. In 2018 TechStream 2, WASM became the default and replaced asm.js. Now, you haven't heard from us in a while, but we do believe we're at a tipping point for Unity content on the web. So why are we doing this? What makes the web powerful? It's incredibly powerful for two reasons. Offering content in this way offers end users that feeling of instant access as they're taken into an experience with just a click of a link or a scan of a QR code. And there's no need to install something onto their device. In addition, when you bring your content into the secure environment of browsers, you have a direct connection between you and your users. There's no app store to get in the way. I thought that was a pretty good point, too. So web doesn't have an installation step like other platforms, which brings the promise of low friction and instant engagement. However, this means users need to download the runtime and starter assets on first load. So for us, for you, our creators, and all of our end users, load time is everything. There's a ton of work being done to reduce load times, and you'll hear more about that in a few minutes from Anthony. So the depth and breadth of Unity Engine gives you the power to handle more complex simulation and interactive elements compared to other web technologies. That said, with users downloading the runtime and starter assets up front, smaller is almost always better in the context of web, at least for now. Given those trade-offs, there are certainly some types of game content that work better on the web than others. Here's a couple of examples. First, there are casual and hyper-casual games with their bite-sized play sessions and easy-to-grasp mechanics. These are perfect for the web. The other example here capitalizes on the low-friction nature of the web by taking a small part of a larger game, say your tutorial level, and make its own web build separate from the rest of the game, and making it available for all users. This allows for a frictionless first-time user experience without installing anything on their device. Then, you can convert the user to the full native app after they've engaged with the mechanics or wherever else your game lives. These are just two examples, and we're looking forward to seeing all the other creative methods creators will think of to harness the potential of interactive content on the web. It was awesome to see that NASA used Unity to build this, the Artemis Real-Time Orbit website, or ARROW. NASA does love their acronyms. An interactive real-time tracker for the Artemis 1 mission launched last November. For those that aren't aware, Artemis is the son of Apollo and will be the series of missions that marks NASA's return to the moon. Using this web app, space fans around the globe could view where the Orion capsule was in its orbit, as well as see its eventual splash site down in the Pacific Ocean. NASA is planning to build on this tool for all future Artemis missions and expand it to track not only the Orion capsule, but all other mission components. So you can use Unity to bring rich, interactive, real-time 3D experiences to the web for your next lunar mission or whatever other marketing activities you have. Now, you may have noticed that I've been talking about devices and showing pictures of phones. It's really odd since Unity has never supported web builds on these devices. But if you saw our keynote, you saw that we have heard your feedback. And there was a lot of it. These are all actually real customer statements made in a single month. So thank you all for being vocal about this. But we've heard it, and I'm proud to reiterate that Unity 6 supports mobile browsers. Thank you. So what does this mean? It means you can run your Unity games anywhere the web exists, including in iOS or Android browsers themselves, embedded in a web view in another native app, or use our progressive web app template to make your game behave more like a native app with its own shortcut. We're confident developers targeting web on mobile will have success with high-end mobile devices released in the last 2 to 3 years, but this will vary quite a bit based on the content. By the time we ship Unity 6, we'll have clearer guidance around the min spec for web on mobile. Here, you can see our recent 2D sample project, Happy Harvest, running on Safari on an iPhone 15 Pro. Some might be asking, well, why roll out support now? What took us so long? Well, a few things have changed in recent years. First, Safari started supporting WebGL 2, so Unity Web works on iOS as well as Android. We've seen continuous advancement in both mobile network speed and reliability, as well as the ever-marching progress of improved CPU and GPU power. Finally, modern audiences have an appetite and appreciation for instant experiences with very low friction. We've all experienced this to some degree with the proliferation of short-form video content. For these reasons, we believe users are primed for short-form gaming content. Speaking of which, as you may have heard in our keynote, we're partnering with Meta to build support for their instant games platforms. Now, what are instant games? Well, it's where users can find and play games instantly on Facebook and inside Messenger conversations. With an audience of gamers in the hundreds of millions, this is a fantastic new platform opportunity for Unity developers to extend their content's reach to an entirely new cohort. There are a number of things the Unity Web team is working on to facilitate this partnership, including a dedicated build target so you can test, build, optimize, and publish your games in a streamlined flow tailored for the instant game use case. There will be a C# SDK to interface with instant game APIs, and a multitude of net new optimizations to ensure users can get into games in seconds. We're also partnering with game studios to prove out and validate this new tooling as launch partners. Now, one of those studios is CodeSync, who have a few games on Meta's platforms, including this one, Ready, Set, Cook. The team at Unity applied some early optimizations to this game, and the results were super promising. With just a 25% drop in load time, there was a 50% growth in active sessions, and a jump from 35 to 58% click-to-play rate. This means that with just the beginning of our optimization work, Ready, Set, Cook went from most players never seeing gameplay to the majority getting into a game with their friends. This is the result of just the tip of our optimization iceberg, but you can see how relatively small reductions in load time can make a huge difference in engagement. But enough numbers, let's see this in action. So here you can see a comparison between the original build provided by CodeSync and the optimized version with our latest instant game ready tools applied. Now pay attention, because in the instant game world, things happen very fast. So imagine you're inside an application, you receive a challenge from a friend, and you say, accept, I will play this. And it's the first time you've ever seen this game. So I'm waiting. Oh, I see something. Oh, and it loads. And you're in. 5.5 seconds. The original build, we're still waiting. We're still waiting. Ah, there we go. So we went from 12 seconds time to interactivity to just over 5.5. Thank you. So this particular test was run on a Pixel 5, throttled to 48 megabits per second. So there's no, high bandwidth trickery going on here. Let's take a look at some more numbers across different speeds. I need to click that. So here you can see what the load times were before optimization and where we're currently using Ready, Set, Cook as a testbed title. First, throttle to 48 megabits per second, as we all just saw on the previous slide. This is the global median mobile network speed as reported by Ookla. It's not even 5G. At the global median broadband speed, 86 megabits per second, we're even faster. And finally, on a median 5G connection here in Amsterdam, we're a bit faster, but you can see we hit diminishing returns as the speed stops being the primary limiting factor. Andrew Moe is the product lead for Facebook Gaming, and although he couldn't be here in person today, he wanted to offer this statement. We share his and Meta's belief that there's a ton of potential in making games instantly accessible, especially when paired with the social graph. Unity and Meta are both eager to see more Unity creators have success on these platforms. So now you might be asking, how the hell are we doing this? Well, to talk about that, I will pass it off to Anthony.
Thank you, Ben. So sadly, we didn't find a load fast button hidden in the drawer that we could just use. We've had to really look at all aspects of the web application to see how we can improve that download and initialization within the web browser. So let's take a quick look at the anatomy of a web game. First of all, it consists of that WebAssembly. That's the binary executable that contains the Unity game engine and all of your game logic. There's a large resource file that goes along with that, .data. This includes global metadata and asset resources for that first scene. You may also have asset bundles and addressables if you've used those to divide up the assets in your game. And then there's a WebGL template, the HTML page, and some JavaScript files to get it all going. So to begin with, there's some best practices that you should follow to create a good release build. Firstly, make sure you select the release build options and optimize for size. That allows our C compiler and linker to do the best job for you. Next, make sure you use compression. Brotli compression is the best, and we can have a setting where we can pre-compress for you as part of our build step. When you do that, you need to make sure that your web server is configured properly. And then we looked at adding HTTP preload tags to the WebGL template as well. This makes sure that any asset bundles or addressables that are used first are preloaded right at the beginning when the page is loaded. And we'll be making sure that these are the defaults in that upcoming instant game build target that Ben mentioned. Next, you should think a little bit about what the user's doing while they're waiting for your game to load. Consider replacing just a simple progress bar with something useful, maybe a splash screen or a video informing them how to use the game. But we need to continue to go further with this. So let's focus a little bit more on that WASM file, that WebAssembly file. This is already fairly well optimized. First, we do what we call managed stripping. You've seen this in the build settings, where unused .NET classes are removed. Then the IL to CPP compiler generates C++ code, which we pass to our C compiler. There, the linker does a sort of whole program optimization where it looks for various dead code elimination and other optimization passes that it can do. but still we have a fairly big WebAssembly file. And this is because Unity is a very rich general-purpose game engine. There are things in there, functional components, that are there just in case they're needed by your game. We have APIs where you can load resources from any URL on the internet. And so we've identified some of these subcomponents that at build time, you can identify that you don't need them and strip these further from the code as well. On the right-hand side, we can see a list of some of the subcomponents we're currently working with. And those that are crossed out are those that we could remove from that Ready, Set, Cook game. Once we've removed them, we then do a further optimization pass, which gives the linker another chance to do more inlining and perhaps dead code elimination for those pieces that are removed. And in this example with Ready, Set, Cook, we removed 1.5 megabytes from that uncompressed WASM file. And we're really only just beginning in putting together these subcomponents. These will be available again in that instant game build target, and there'll be a mechanism for you to select them manually and tools to identify which can be safely removed. So this helps get the build down even smaller still. Another benefit with this is that as well as downloading a smaller payload, there's less work for the browser to do when instantiating a smaller WebAssembly file. And this is great on mobile. Let's take a look now at the assets that we have. That's the other main piece of the puzzle. And so again, depending on your game, the assets may be bigger or smaller than the corresponding WebAssembly. And so here there are a bunch more best practices that you need to employ. Since that time at the beginning is super critical, consider using the Unity addressable system to break up the assets and only load those which are needed for the first scene. Then, other assets will get loaded on demand as they're needed as you progress through the game. If there's lots of audio in your game, consider reducing the quality of that, use compressed audio, and so forth. Likewise, we have suggested settings for graphics. ETC Crunch gives the smallest texture sizes and saves again on that download time. If you're using ASTC compressed textures, look carefully at the block sizes used in different textures and try increasing them. It still looks really good. Likewise, there are settings for shader stripping and graphical quality that you should look at. We'll be producing some better documentation next year, outlining how to best use these settings to the greatest effect. Putting all of these things together is what you need to get the fast start time that we need on the web. So that WebAssembly technology that we talked about, this is really foundational for how we can run Unity games on the web. And as Ben says, gives us that near-native performance. This technology isn't standing still. And on the web, we're really grateful for the whole work that the web community does to advance and support these technologies. Web gaming just isn't possible without the investments and supports from other browser vendors, and we particularly appreciate the collaboration we have with the Chrome team at Google. Together, we've worked on strengthening gaming use cases for WebAssembly and graphics performance for complex gaming workloads. So first, we have the mscript toolchain. This is what takes that C code that comes out of IL to CPP and builds it into the WebAssembly for the web. With each new LTS release of Unity, we've brought the new mscript toolchain to you, and each one of those reduces the time taken for developer builds. So if you've done web builds before on a fairly old version of Unity, try the latest one. You'll find that the development builds are now much, much faster. Likewise, we're enabling much more optimization settings from that LLVM compiler and linker. Those release builds now take longer, but they give you much more optimized builds. There's a 4 GB memory feature coming. Currently, in WebAssembly, your games are limited to 2 gigabytes of memory that Unity can use, which is fine for most games. But for more complex real-time 3D experiences, particularly when using desktop browsers, often you want more memory to loading richer, bigger scenes more dynamically. And so in Unity 6, you can now turn on 4 gigabyte memory support. And the work we've done here paves the way for future 64-bit memory support for even bigger memory limits. There's a couple of more WebAssembly features coming too. If you look at your code, you often use exceptions to catch error cases. When you have that turned on with web builds, with WebAssembly, there's been some overhead to having that. Turning on native exceptions in WASM allows you to still have that exception support, but with very little overhead. So again, we're shrinking down those build sizes for you. And finally on here, we've now enabled WASM SIMD. This is a newer feature that's come to WebAssembly, and it accelerates any mathematical calculations you're doing on the CPU, and replaces those single instructions with vectorized instructions. It works on both desktop and mobile devices as it maps those WASM instructions to the appropriate SIMD, SSE, or ARM Neon. A good example of where this makes an impact is in character skinning. With web builds, you do this with CPU at the moment. And when we've turned on the SIMD support for the character skinning, we can see improvements that range from 7 to 20%, depending on the browser and device that you're using. So if your game title has a lot of mathematics in it, or a lot of complex manipulation in your code, turning this on could have a noticeable impact just for clicking a button with Unity 6. These features are, however, only available on some of the newer browsers, so they are build options that are coming. So depending on whether your user base moves forward to newer browsers and newer devices or not, you can choose them optionally. But it's not just WebAssembly that's moving forward. It's a fantastic time for graphics on the web with WebGPU. And WebGPU is really a significant milestone for graphics on the web. And it really paves the way for the next set of unprecedented leaps in graphics rendering performance. WebGPU is designed with modern GPUs in mind and brings those capabilities to the web. In the browsers themselves, WebGPU is built on top of DirectX 12 or Vulkan or Metal, depending on your device and machine that you use. Similar to other modern graphics APIs, it provides that potential for more optimization opportunities, both on the CPU, due to the more modern nature of the API, and the GPU, because of improved throughput. And for the first time, it brings compute shaders to the web. And if you've been listening to many other talks that happen here at Unite, compute shaded is one of the technologies that's going to underpin graphics features going forward. So we're really excited that this is coming to the web, and we'll continue to bring web games along with those new features. Thinking of that skinning example we just saw that was done on the CPU, we can accelerate that further with a compute shader with GPU skinning and have that massive parallel capability on the GPU. Another example is Unity's VFX graph, which uses compute shaders to manipulate that geometry, again, all on the GPU. Let's take a look at some demos. First one of these is something that you may have seen a long time ago. This is Boat Attack, which is one of our sample projects we have. Here it is running on this Mac M1, entirely on WebGPU. The frame rate is here cranked up to what, 120 frames per second?
When it's not hooked up through this, yes.
Yes, when it's not hooked up to our video
capped
system.
to 60, unfortunately, but
it works really, really well. The next one of these is Viking Village. Again, this is a sample that's been available on our asset store for a long time. Here it is on Unity's graphics backend, running on web GPU. And when it gets going, it is better than 2 frames per second. So I'm not sure it's quite correctly measuring it there. We've been focused on building our graphics backend to get web GPU up to parity with WebGL. But let's see what else we can do with it. We talked about that character skinning. Here we're using GPU skinning to mesh this robot onto the skeleton underneath. If this was done on the CPU, it would be running at about 7 frames per second. So we can now really see what the GPU lets us do with things like this. You can move it around too. And finally, we have VFX Graph. Here we're doing a particle simulation. In this simulation, we have just over 500,000 particles being animated. And they're all being moved through compute shaders on the GPU. So let's see. Where do we go from here? Web GPU is available today on Google Chrome and Microsoft Edge on both Mac OS and Windows. And our graphics team at Unity has been working really hard on Web GPU. And with their development, we've been working really closely with the Chrome team again at Google to stress test those web GPU implementations with really large scenes and complex shaders that we use in games. And it's really beginning to produce some fantastic results. Our web GPU backend is still in development, and we don't yet recommend using it for production use cases. However, early access is available today. If you go to the Web Platform Forum, you can find a pinned post which will tell you how you can try these demos and how you can try it for yourself in the latest Unity 2023.3 alpha. We can't wait to see what you're going to make with this on the web. Post it somewhere, give a link to your friend, and get them straight into this level of graphics fidelity. Now I'll pass it back to Ben.
Thank you, Anthony. Live demos are awesome, always. And it's always wonderful to see beautiful scenes running in a browser environment, easily accessible. Now, we have one more thing to announce today. The platform of WebGL is now known as simply Unity Web. Why are we changing this? Well, we want to separate WebGL, the technology, and Unity's web platform. We also want to prepare for a future with more than one rendering standard, as Anthony just gave a glimpse into the future with Web GPU. You'll be able to create a build using WebGL, one with Web GPU, or a single build with both. So to recap, web is incredibly powerful because of its potential for frictionless engagement and a direct connection with your users. Because users download the WASM and starter assets up front, reducing load time is critical for web projects to realize that frictionless potential. And because of those trade-offs, their typically smaller pieces of content are best suited for the web, at least for now. We're investing a lot here, and we're so excited for you all to use the new optimization tools tailor-made for web projects. As far as what's coming soon, mobile web support starts in Unity 6. Coming late next year, build and deploy your instant games to Facebook and Messenger to access a whole new audience. And if you're the tinkering type, go read our forum post about WebGPU, which is coming to early access, well, right now, on that alpha. And that's it for our presentation, but we would be happy to answer your questions if you have them. We'll head over here. Thank you.
Thank you.
Well, hello everyone. Thank you so much for being here today. Good to see you all. My name is Benoit. I am a senior product manager at Unity and very excited to be here today to give you an update on UI Toolkit. So we have a packed agenda. I'll start with an update on the state of UI at Unity, and then we'll dive right into what's being released for Unity 2023.2, and then we'll wrap it up with some insight about what is currently in development. And we should have time at the end for some Q&A. So back in 2021, when Mechanistry were developing their Beaver Team city builder game called Timberborn, they got to a point where they asked themselves if they should be using UI Toolkit for their project. They used UGUI in early development of the game, which back then was the only solution Unity provided and supported. And they were pushing its limits as Timberborn grew more complex. A lot of times building elaborate screens and trying to get everything aligned together just broke layouts, and reusing assets was challenging since logic is tightly coupled with the view. And because the UI assets are not human readable, they were continuously running into merge conflicts. Some of them can be resolved automatically, but other times they're not, and they have to recreate the prefabs from the ground up. So they felt like they were being slowed down by the system. So they wanted to release Timberborn in early access on Steam, and when you do so, it's critical to be able to iterate fast and improve the game based on that early feedback. And you probably know that city builders are quite complex, and they wanted to make the game more approachable and just more intuitive, so they could keep growing that player base. And you can achieve some easy win by improving the user interface of the game. So Mechanistry looked at UI Toolkit's roadmap and decided to take a deep dive in the technology to better understand its capabilities, but also its limitations. They thought it would be a good fit for their project and was worth migrating the entire UI before they released the game on Steam. And this would also be a good opportunity to clean up some of the code architecture and pay off some tech debt along the way. So a programmer and an artist sat down and recreated more than 60 screens and widgets over the course of a 9-month period. And soon after, building UI went a lot faster. So no longer have to deal with merge conflicts. It allowed them to have better separation of concerns for their UI logic. So now they can work on different parts of the UI simultaneously, and also test components in isolation, so resulting in fewer broken builds. It's also easier to create more complex, so they've added things like scalable UI and hidden menus into their game. But best of all, because they improved the UI, but also every aspect of their game, they achieved overwhelmingly positive rating on Steam, and that's a great achievement. When we asked Pavel to share with us his experience with UI Toolkit in Timberborn, he said that in UGUI, making a working prototype can take 1, 2, or 3 days, depending on the complexity. But with UI Toolkit, you can have a working prototype in a matter of hours. And that makes a huge difference in productivity, especially when you build a lot of UI and you want to be moving fast in this highly competitive market. So if you want to learn more about their experience in using UI Toolkit, we've made this case study that gives you all the detail about it. And make sure to visit their website and check out Timberborn. It's a beautiful game, and it's a lot of fun. So it worked for Mechanistry and other games, but will it work for your project? And I get this question quite often, and we're not really the ones that are able to answer that for you. All I can say is UI Toolkit has been released and supported for many years now. And even though it's not yet at parity with UGUI, it remains a viable alternative for many projects. But we always recommend for you to do a thorough technical assessment and evaluate if the technology is a good fit for your project. You can also keep an eye on our roadmap. We're continuously releasing improvements, performance optimization, and adding new features. And speaking of new features, now we're going to go over what is being released in 23.2. So for this release, we focus on improving the foundation of UI Toolkit before we continue growing the feature set. So that work is divided in 3 main categories. We wanted to make it more efficient to build dynamic user interfaces and make it easier to create custom controls that are also more easier to configure. We also felt some of the system were a bit complicated and complex and difficult to grasp, so we updated the event system, which is now easier to operate and behaves more consistently. The new input system now has runtime support integrated and no longer requires UGUI in your project to use. And we've also added a few new controls to the standard library. And we improved the button, so now it can display icons with or without text. But for today, though, we're going to focus on the first category of features that will increase development velocity. And we'll go over them by building a very simple yet very common UI found in many games, just a player bar displaying a player's health and its a player's name and health. In most cases, you need UI to display dynamic information reflecting the state of the game, right? You could be pulling data from a server or just updating game stats like a player's score or a player's health points, which will most likely change a lot throughout the session of the game. So here we have our UXML defining the UI, and how you would normally connect data to it is by using uQuery to retrieve each element by either their name or their type or a USS class and assign new value to them. And in the case of a player's health, you also need to ensure it's continuously updated throughout the session of the game, right? And the feedback we heard is that this can be a bit tedious for 2 main reasons. First, when you have many elements, it requires a lot of boilerplate code to write. And even though strings can have some advantages, string references have some advantages, it makes the contract between the UI and the logic a little bit weak. Like you only need to make one simple change in a UXML or USS and the whole thing breaks. And those changes are usually challenging to track down and fix. So what if instead you could define what kind of data to connect to the UI directly into the UXML? So this is where you would declare a relationship between the model and the view and have a much better separation of concerns. And at first glance, you're like, well, it's a similar amount of code, but what if all that new UXML code could be generated for you? Then all you need to do is connect your data source, and everything will be resolved automatically. So that's what we did. We built a new data binding system. It works for both runtime and editor UI. You're not limited to use data types that are supported by serialized property. Any plain C# object can be used as a data source. And you can target multiple properties on the same element, ranging from visual element attributes to style properties. And it's fully extensible. You can create your own binding types and attributes. So many of you also find it important for artists and designers to work closer with programmers within a project. So we made sure the UI builder can be used to create and modify most aspects of data binding using visual workflows. So you start by assigning a data source to a visual element, which will then be made available to all of its children. And you can decide at any moment to override that data source in your hierarchy if you need to, and this will take precedence over its parents. So when setting a data source, you have 2 choices. You can set a type, which is just a type information. There's no instance being created at this stage, so no binding will be resolved. However, this can inform the UI builder of what type is expected, so later on, when setting bindings, it can provide assistance for you. Or alternatively, you can set a scriptable object asset from your project, and this is an actual instance. So all the bindings you define in there later on will be resolved live in the editor. So this is very useful if you want to work with a representation of your data and play around with some values and see the changes live in the UI builder. And optionally, you can set a data source path if you want only a certain part of your model to be made available to your bindings. And to set a binding, it's as easy. You can either go through the triple dot menu or just right-click on an attribute or a style property, and you select Add Binding, and you will be presented with this new dialog that has everything you need to properly set a binding. This is where you can override the data source if you want to. And then you set the path of the property in the data source. So if an object or type was specified as the data source in the previous step, the UI builder can suggest a list of parameters to choose from. It provides auto-completion and gives you useful information about them. There's also an option for specifying a binding mode, and you have several options to choose from. So you could want an input field and a data source to remain in sync whenever there's a change in either of them, or just have the input update the source. In our case, we want the opposite, right? We want the source to update the UI. And there's also an option for if you want the UI to be updated once and only once, if you have, for example, localization strings. Then we'll go and click on Add Binding. Then you can notice the affordance in the inspector now informing us that the value is coming from a data binding. It's also telling us the binding is resolved because it's coming from a scriptable object. But the binding could also be unresolved, and that's a perfectly valid state. The system is just informing us that even though the binding is properly configured, it doesn't have any data source connected to it yet. So it's on us then to provide a data source at runtime, and when we do so, everything would be resolved as expected. We're also using that new affordance for communicating when the value is coming from other sources, such as inherited from a parent, coming from a selector, or a variable. And the tooltip provides a very useful information about its origin. So, like I mentioned before, any change to a connected scriptable object data source is immediately reflected in the UI. And that's true for the UI builder or the game view. You can also define your bindings only using C# code, if this is what you prefer. So if we recreate the same UI in code, this is what it would look like. There's an API for creating, modifying, and setting bindings, just as you would do through UXML or the UI builder. To define a data source for runtime bindings that can also be used for authoring or serializing purposes, you can use a common pattern like this one. So the serialization goes through the field, and the binding goes through the property instead of the field. So this allows you to do validation, change notification, or any other operation. And the third one is similar, but for auto-generated properties. So we didn't want the binding system to make any assumptions on how you want to manage the updates from your data source. So by default, it would pull the data and update the UI on every modification without actually knowing or asking if anything has actually changed since the last update. So this works well for very simple projects, but doesn't scale efficiently especially when you deal with a lot of bindings. So to increase performance, you can integrate both versioning and change tracking into a binding data source. And so you can tell the system what to update and also when to update it. These are optional features, but if you see bindings taking a lot of resources in the profiler, you may consider implementing them to minimize the processing overhead. To integrate versioning, you just implement the iDataSourceViewHashProvider interface. It enables the binding system to skip updating certain binding objects if the source hasn't changed since the last update. The interface also buffers changes, which is very useful when the data changes frequently, but you don't want necessarily the UI to reflect those changes. So in our example, for the health of the player, it could change many, many times during a single frame, but that information doesn't need to be conveyed to the UI on each of those occasions. So you buffer the changes, then you call the commit changes method to to notify the binding system that the data source has changed, and now I want to update my UI. And by default, UI Toolkit will update all bindings associated to a data source. So if you need more granularity, you implement the iNotifyBindable property change interface. This allows you to instruct the system to only update certain properties and not all the bindings. And of course, if you want to achieve optimal performance, you can implement both of those interfaces in your data source. Sometimes you need data to be converted between the source and the target of the UI. You might have data that is completely different from the UI. You could be using an integer or an enum to do a lookup in a table and retrieve some texture to be displayed in the UI. Or in some other cases, you might want a different representation of the data. For example, if you have angle that you want to display in degrees instead of radians. UI Toolkit comes with a list of pre-made converters, but you can also supply your own. So a simple example for our player health UI would be to convert a numeric value to a string and append a percentage symbol to it. You can define individual converters or group converters like this one, which are very useful to handle permutation on the same conversion. The method for adding a converter requires a delegate to convert a source type to a destination type, and the delegate must be a ref delegate to enable bidirectional usage. And then all we need to do is register our converter group. And once that's done, they can be assigned to a binding using an API or directly from the UI builder. So if we go back to edit our binding and go into the advanced settings, now we can assign our newly created converter. And because the UI builder is aware about the types of the source and the targets, it can propose only the converters that are compatible. And once assigned, the value is sent to the UI, converted as expected. Right? So as you see, the value did not change, right, in our data source, but now the UI has a different representation of it. So far we've been looking at data bindings, and it's possible to also have other kinds of bindings. The binding system comes with an extension class that provides what's needed to creating your own custom bindings. They can be useful if, for example, you're dealing with custom types that are not natively supported by Unity, or when you don't need a data source. So using an example, Unity is also using custom bindings to create other types of binding as well. One example is the serialized object data binding system for the editor UI, which is still available. We rebased it on a custom binding so we can have a shared implementation for all binding systems. And it's worth noting that since we have that, now we can continually improve it. So we're planning to have a deeper integration of that system with the new binding system and add supports like custom converters, for example. We're also developing a localization bindings for adding support for UI Toolkit in the localization package. So this is a perfect example of a binding having a different set of requirements than regular data bindings. So an example of a custom binding implementation. When the binding system tries to resolve a binding, it's going to call the update method and expects a binding result, hopefully successful. But let's say our localization system makes asynchronous operations to load string tables and then assign strings value to for a given locale. Then if those operations are still ongoing when the update method gets called, we just return a pending result to ask the binding to try again later. And then when it gets called again and everything is ready, we can set the property on the element to the translated text, and we do so using our converter groups because we want to make sure all the registered converters are taken into account when the value is assigned. And this time we can return our result as a success. And at the bottom here we have an example of a localized string binding in a UXML document. See, it looks a lot like a regular binding, but with its own specific attributes for fetching an entry into a localization table. Also notice it sits under a bindings element, just like data bindings, and you can have a mix of different bindings under that element node. And for those of you with a keen eye, you may have noticed this new UXML object attribute, and we're going to cover this in a moment. So our UI is bound to a data source displaying converted values, functioning as expected. But I think at this stage it's fair to assume that most players would expect an actual health bar instead of a textual representation. So I'm going to go ahead and create a custom element for that. So we'll create a new custom health bar by extending the visual element class. We only need two elements, a background color and another bar for displaying the actual representation of the player's health. And whenever the player's health changes, we need to make sure to update the width, right, of the player's bar accordingly. And then to allow our custom element to be used using UXML or the UI builder, we need to implement what we call the UXML factories and traits. So a factory is what creates instances of an element. It also takes care of generating all the inherited attribute of visual elements. And then for each property you want to expose to UXML as an attribute, you need to create a trait by specifying its type, its name, the name that you want to in the UXML attribute, and a default value. And then finally, during initialization, you need to get the value for each of those attributes and assign them to your element. So you told us that this requires also a lot of setup, and more so because you can't really predict what's going to happen into that init method. And because all of that setup requires a lot of strings to be parsed, we're kind of limited on how we can optimize instantiation times. So we improved how UXML gets serialized. We wanted to make it faster and more intuitive to create custom elements, and also while also providing the familiar Unity features you rely on, such as serialization, property drawers, decorators, and so on. So with UXML serialization, this is how you would expose UI elements to UXML. So we're going to go over the few differences. First, to declare a custom control, you now use a UXML element attribute, which replaces the UXML factories. Each attribute now only requires a UXML attribute, no more UXML traits. And the attribute name is automatically derived from the property name, although you can, if you want, specify a custom name, you can do so as an argument in the attribute. And the default values are directly assigned to the field. And it requires the class to be marked as partial, because we're using some source generator. So when your code compiles, we detect all of those attributes, and we add new code to your classes that handles the serialization. So now we can replace our standard label with our new health bar, and we just need to make sure that the data binding reflects those changes. We had a binding to the same health property in the data source, but now it targets the value property of our health bar instead. And that's pretty much all we need to do. There's no need to change any code or modify the data source in any way. Now with that, we can do even more. So let's add the ability to customize the health bar so it changes color when reaching a certain percentage. For example, it would start green. When the player reaches 60% health, it turns yellow, and red at 30%. And for maximum flexibility, we could have any number of those health markers, which could be of any color. So a regular player could have 3 colors, and an enemy boss maybe go through 5 of those. So let's go ahead and create a new class to define those markers, which we'll name health marker, and only needs a position and a color. And then we add a new property in the health bar element that will hold a list of those markers. So this is all fine, but UI Toolkit has no idea how to handle the conversion of our health markers into UXML. So, because when a system sees a UXML attribute, it knows that the field or the property is linked to an attribute in UXML. And Unity will automatically handle the conversion of values to and from UXML attribute strings as needed. And this conversion is done through the use of what's called a UXML attribute converter. So this is great because we can create our own custom converters to instruct the system how to go ahead with that conversion. And to do so, we create a new class that extends the UXML attribute converter. And then we just need to override 2 methods that instructs how to go from a type to a string representation and vice versa. And then at the bottom, you can see what that representation would look like in UXML. We have our 3 markers separated by commas with their positions and color. And of course, these can be picked up by the editor, and they can be edited like any other attributes. So this is great, right? We can extend custom data types by defining our own UXML attribute converter, but you can run into certain limitations as your data types become more complex, or you're dealing with large lists of objects, which would make the generated string either less readable or more complicated to manage. So the notion of a UXML object, which is essentially an element that can be a child of a visual element, has already been part of Unity. Well, in UI Toolkit. So if you have ever authored a multi-column list view or a multi-column tree view, you may have encountered them. They're essentially, like you would notice, a columns element which holds a list of columns. So we enhanced this feature and made it available for defining our own UXML objects. So here we're going to convert our health markers to use UXML objects instead. So as you can see, they look a lot like UXML elements. We're using UXML attribute for attribute declaration and the UXML object attribute instead of using UXML element. And just like UXML elements, it also requires the class to be marked as partial. Also noteworthy is instead of using the UXML attribute now, when using a UXML object fields, we introduce what's called a UXML object reference. This allows us to specify a name that will indicate that the UXML objects will be parented to an element with that same name. But it's optional. If you don't specify one, they will just be serialized at the root of the node. So that will generate that. So that's the UXML with now our new health markers, which is much more readable and scales a lot better, right? If we keep adding additional health markers, it's much more convenient to manage. And of course, you can edit UXML objects directly in the UI builder. So then the last thing we need to do is update the value property of the health bar. Here we can do validation, like an early exit, if the value hasn't changed. Then we look for some health markers that would match our new value. And if we find one, we assign its color of the health bar's background with the color of our health marker. And lastly, we notify the binding system that the value has changed, and we can update the data source. So there it is. Now our health bar is able to shift between different colors, any number of colors, and those markers can be authored directly in the UI builder. So now that we are using serialized fields through this new UXML serialization, we can support custom property drawers, just like a scriptable object or a model behavior. So those are very, very useful if you want to improve the usability of custom elements and custom types. So let's go ahead and add some predefined property drawers to our custom element. As you would expect, they can be used to decorate types, properties, UXML elements, and UXML objects. So here we're going to use a header decorator for making a dedicated section for our health settings in the inspector, so they're easier to find. And I'm a big fan of sliders for changing values, so we're going to add those to the position property of our health markers. We don't have time to go in depth on how to create custom property drawers. I mean, they're not a new feature. They've been around for a long time, though there's a lot of existing material if you want to learn more about them. I just wanted to let you know that they are now supported by the UI builder. So let's add a final touch to our UI. I found the color change between those markers to be a bit choppy. It would be more pleasing if the shifting of colors was a bit smoother. So, and this is a perfect use case for USS transitions, which have been around since 2021. So again, this is not a new feature, but they're great for this kind of UI. They don't require us to specify a start value or an end value. Anytime the value changes, it animates the transition between the existing value and the new one. And so for this case, we just want to set the background color to transition over 0.4 seconds. So again, same UI, now with more smoothness. So it's one of those simple changes that can have a big impact on how the UI looks and feels. Okay, so let's recap. We looked at how UI Toolkit now makes it easier to build and customize UI. With the new data binding system, makes it easier to connect live data to your UI, which also works at runtime. And the new UXML serialization streamlines the process of creating custom elements, but also provides better control on how they are exposed in the UI builder. So I hope you find these new features useful and improve your day-to-day as you work with UI Toolkit. And please let us know if you enjoy them or if you see anything that you would like to be improved about them. All right, so we're going to spend the remaining time we have to look at what we are currently working on. So what has been released in 2023.2 concludes the second phase, our roadmap. Now we're shifting our focus to provide the features and capabilities to make UI Toolkit our best solution for creating immersive and dynamic UI for games, but also XR experiences. So we're not going to cover everything in the details, but I wanted to highlight the most important ones, which were prioritized based on your feedback, which we always appreciate, so thank you. So we're working on a solution to animate complex screens like a startup screen or a result screen, and for that you need the ability to create keyframe animations and sequence them together, and even combine them with other kind of animations. The second area of focus is being able to create more sophisticated UI styling by using custom shaders. So we can produce advanced visual effects like blur, glow, drop shadow, or any other kind of visual enhancement. And thirdly, we also noticing an increase in requests for making games available to more players. So we're working to add full multi-language support, which includes right to left languages like Arabic and Hebrew. And like I mentioned earlier, we also want to make UI Toolkit work with the new localization package. So we're adding support for that. And Unity also recently released a new C# API to interface with native screen reader on mobile devices. So we're going to build on top of it. So UI Toolkit will produce UI that works with them out of the box, and we'll add support for desktop as well. And lastly, you requested to have UI that can be rendered in world space. So in our internal dev build, we're exposing this capability via the panel settings, which now has a new render mode option. So when selecting world space, UI can now have 3D transformation applied to it, and is fully part of the game scene. The implementation is not using render textures or similar methods. It's fully integrated into the render chain. So this allows for textureless UI to remain crisp and beautiful at any size or distances from the camera. And of course, all other UI Toolkit features works as expected, such as styling, animation, and input. So we're, of course, super excited to be working on this and can't wait to make that available. And one last thing before we leave, we also have a new sample project in the asset store. We've heard that it's not obvious to how to get started with UI Toolkit, and especially how to create a code architecture that will scale well. So this project shows how to use certain design patterns like patterns with UI Toolkit, like the model view presenter, the state pattern, and how to manage many screens in a project, and many other things. So feel free to check it out. All right, that's all the information I have for you today. So thank you very much. Yeah.
Okay. Hello, everyone. Welcome to my talk about Memory Profiler 1.1 and how you can use it to improve performance of your application. Well, a little bit about myself. I am Anton Kruglikov, senior software developer, profiler team in Unity. My primary field of work, all the low-level stuff in Unity Profiler and Memory Profiler. And that's why advanced warning. This talk would be quite a lot about low-level stuff. How memory works on the operation system was quite a lot of theory. So no video, no audio, no funny stuff, just boring black text. So let me tell you a bit about what this talk is going to cover. I will start with overview, a short introduction of what we will look at, what this talk will cover, what's not. The next topic will be resident memory. It's a new addition to Memory Profiler 1.1. I will show you why we added it and what it is useful for. And the last will be about, we'll analyze memory snapshot by looking at each category in it, and we will talk about all of them in the context of new available information about resident memory. And the last one will be about untracked category. I want to dig into what is untracked, what usually hides there, and how you can analyze it. So my goal by the end of this talk is just for us together to understand what Memory Profiler shows you, understanding what are allocations, what's your in physical memory, why new resident memory was added, and what it gives you, and how all of that affects your application memory footprint and performance. Well, question to the audience. How many of you use Memory Profiler? Could you please raise your hand? Oh my God, okay. Well, I mean, it makes us happy. It means you use our tools, which is nice. So let's begin. So I will start with the overview. For this talk, I've made a snapshot, which I'm going to use through all my slides. And it was taken from Android game. And obviously, because it was taken on Android game, it has Android bits. But apart from this small section, which is Android specific, all the rest are universal and applies to any platform. I'm not going to cover manage/garbage collected memory much, as this topic is well covered. I think we have quite a lot of YouTube videos, tutorials, documentation, and blog posts about that. So there will be a link at the end of the presentation, but this talk will be more focused on low-level stuff, and the talk is kind of less about what you allocate directly and more about what is being allocated for you. Because Unity operation system and third-party libraries could allocate. And yes, that's what we're going to focus on. Also, it's about allocations which might look scary in some review, but in reality might not be what is actually affecting your memory footprint or application performance. We'll talk a bit about how operation system manage memory, so that would be theoretical part, and why some big allocations can be ignored or not as scary as they look like. And before we dig into the captured memory snapshot, as I mentioned, we need to spend some time on theory, and the theory would be mostly about two particular terms. Through this talk, I will be using term allocated and resident. We had kind of a set of updates through Memory Profiler where we changed what terms we have used because we used committed, and now we realized it kind of not what we actually showing. So the latest profile, it used specifically two terms, allocated and resident. And I want to make sure that we're on the same page what they actually means. So in simple terms, allocated just how much memory has been requested. And when you request it, operation system makes a promise that it will be able to provide you that memory. It does so by committing physical resources, like system memory or space on disk. Many platforms, for that reason, because operation system needs to commit resources, call this memory committed, well, specifically on Windows. Well, if for some reason the operation system doesn't have enough resources to commit, you will get out of memory. Here, as always, we have multiple platforms. Well, I have to make a note because it's not actually completely true on Linux, because Linux allows you to overcommit, but we will get to that later. And the next big thing is resident. Resident is, well, strictly speaking, is what is actually currently present in your physical memory. And not all allocated memory is actually resident. And that could be for quite a lot of reasons. And they are, well, the memory just could be empty. So you or somebody allocated memory but never used it. Operation systems are quite clever, so they just know how to mark these kind of memory regions as empty, and they don't contribute to your application memory consumption because they are never present in actual physical memory. Well, the second biggest, well, most common reason, it hasn't been accessed for a long time. This is much more platform dependent because it can be moved to a secondary storage like swap file, and this is commonly can be found on desktop platforms. But as well, it could be in compressed memory, which is desktop and mobiles as well, because on iOS you have compressed memory. And the last most important reason would be if for some reason the operation system needs physical memory right now for something else, and that something else is actually more important for operation system than your application. Most likely, if that happens, you're probably already running low on memory because operation system needs to start at least juggling what it can load and unload. As well as why is it important is that as soon, even before you get to that, you actually start experiencing performance regressions. Because in modern operation system, there is no such thing as free memory. All the memory which is free, mostly used for different caches and, well, caches. Even if it's not about caches, you have map files which are being made resident because you access them, and, well, they've been discarded, so after that they need to be reloaded again, and any access to secondary storage is pretty slow. I will going to cover that in more detail when we get to executables and mapped category in our snapshot. And the last one, as you can see, is dirty. For the rest of the presentation, we'll only use allocated and resident terms, but I think because in some tools you will see these term used, so I think it's important to cover it as well. In short, dirty just means modified. So if it's the part of memory that operation system can't easily discard, which is currently present in physical memory, because it doesn't exist anywhere else. Well, from the point of view of operation system, not all resident memory is dirty, because, well, whenever, for example, you have map files, operation system load part of that map file into memory, but actually it can discard it at any time because the same data that is loaded into memory exists on disk file or on disk. So, it just considered that whenever it's just dirty, it's just the limit that operation system cannot go below at any case, well, unless it can be swapped into swap file. To summarize it all, just consider allocated as what you have requested, if you want a short and simple summary of that. And resident is what is currently physically present in memory. It's kind of like very simplified, but if we focus on this too much, we're probably going to spend the entire day discussing it. And before we jump into like looking at actual snapshot, I want to talk about like what actually allocates memory apart from like your script. So before Memory Profiler 1.0 and Unity 22.3, we mostly showed you only Unity allocations and mono/alt/cpp virtual machine state, like heap. But for Memory Profiler 1.0 and 1.1, and we just wanted to reduce to the minimum the amount of like memory, like the difference between what you see in Memory Profiler and what you can see in any native operating system like profiling tools. I don't know, or like Task Manager, Activity Monitor, or any profiling tool, well, of your choice. So that if you open like Task Manager, you will see the same amount of memory, roughly, because there's kind of like different ways to measure what the total what total memory is, but they will be quite close. So for that, we need to show you all allocations, not just what Unity makes directly or like Unity makes directly. All allocations associated with your application. And most importantly, when we talk about all of memory, well, obviously you don't want just learn how much, because, well, it kind of like gives the information, but it's not very actionable. But as well, you want to know who allocated it, which allows you to act on it. And talking about like allocation sources, the first one I want to talk about is shared libraries. Your application's code relies on quite a lot of external shared libraries. These shared libraries might in turn rely on other libraries and so on. All of them contribute to your total allocated memory and obviously your application's memory footprint. Well, just a simple example, you on Windows use DirectX, which uses some kind of like graphics drivers, and drivers use system libraries and so on. So all these libraries will be loaded. All of them, well, will be mapped into your application's address space. They will use some kind of like some amount of physical memory, as well as they will going to do allocations to maintain their own states. The next important one is like runtime environment. It's not present on all like platforms, but in some cases, operating system might need a special virtual machine for your application to run. Most common example, or most well-known, would be Android runtime. On consoles, we can kind of like think about SDK libraries that provide the operating system-like environment as this kind of like runtime as well, because they do allocations as well. Another big source could be drivers, operating system drivers for different devices like video, network, audio. Drivers might allocate in direct reaction to your actions, like you requested texture, and it allocates texture for you and does allocations for that. Or maybe just like to maintain an internal state, like buffer to communicate with a device, for example. And the last important source, like apart from like Unity and like the previously known, let's call it that, is object that operation system needs to maintain its context. It's like threads, stacks, heaps, and so on. All of these contribute to your total allocated memory of your application, and obviously need to be accounted, and might be quite significant. We'll talk about this in detail in Untracked, but I will just give you an example of my recent case. People ask me to investigate why we have like almost like 2 GB of untracked memory on Linux empty project. Well, Unity by default on machines with like creates almost like a 2.5, let's go like 2.5 thread per core, and on machine like with lattice like Threadripper, you can easily get to a state of like 200 or 300 threads by default. And unfortunately, Linux request around like 8 megabytes stack for each thread. So you can multiply, and you will get just almost 2 gigabytes allocated just for maintaining thread stacks. So this information is quite important and can kind of raise a lot of questions about why so much memory is being used. So let's move to the practical part, and let's take a look at actual memory snapshot. As we move to that part, as I mentioned, I took snapshot from Android game. For the talk, we assume that the game targets device with 2 gigabytes of memory. So they just to set kind of like environment and expectations. And let's kind of like think that we open that snapshot and look at the summary page, as you can see it in here. And yeah, as I mentioned, like we agree that device will have 2 gigabytes of memory, and immediately we see like in allocated memory distribution, the total allocated memory is surprisingly 2.2 gigabytes. And yeah, as I mentioned, like we just agreed our device have just 2 gigabytes. So are we in trouble or not? Like it does look like our game is not going to run on our target device. And surprisingly, like it's quite a small game, but we can see that Android runtime and executables and map is taking surprisingly a lot of memory, like 60 to 70%. And you might think like, okay, that's my most, like, that's like the trouble is. But the question is, if we take a look at the like section above, memory usage on device, and it doesn't look like where we need so much space. So just why is it like, I mean, it does say like that the amount of physical memory being used is just well, around 500 megabytes, which is well within the limit that we set for ourselves. So the question now is just like, are we in trouble or not? Because, well, it does look like a bit confusing. So let's take a look at all the categories and, well, see what's in there to understand, are we actually in trouble or not? So we start with Android, like from the biggest one, Android Runtime. And Android Runtime is just like a virtual machine that which runs Java bytecode on Android platforms. It's kind of like similar to Unity, like Mono or LCPP virtual machine. It manages heaps, have garbage collector, compiles bytecode in native code, and so on. All Android applications, well, apart from System one probably, all Android, like typical Android applications, like share Android runtime heap, and because applications use it, we need to show it in memory profiler just to see to show you the full picture. Because, well, applications might be different. Some might be quite lean on the Java part, but some can create objects in Java, Kotlin, allocate in the heap, in the Java heap, or use third-party SDKs and toolkits, which do have quite significant Java part. Unfortunately, if you read about Android runtime, you actually don't have any control over its size. It's being defined by your phone vendor, and the size is being set at initialization of operation system, so it kind of like allocates at your phone start and doesn't change after. So does it mean that Android runtime contributes a lot to your memory consumption? But if you look at the resident memory size, it's just 4 megabytes. So if only like just tiny fraction of it, why do we even include this? Well, as I mentioned, all applications are different. Like first of all, like all applications are different, and you might have a bigger chunk in here, and then in this case, you will need to analyze. The second one is that, well, we just agreed we're going to show you all allocations which are associated with your application, and Android Runtime is definitely associated in your application because it's being mapped in your application's address space. So, if it's like that, does it mean like we don't need to analyze it? The answer is no, but it depends. So in this particular case, you need to focus on resident size rather than allocated size because allocated size doesn't give you any information. And in our application's case, it's just 4 megabyte, and probably we won't be able to reduce it any further and compare it to the rest of 400. It does seems like a pretty small size, so it does seems like it's not a problem for our application. Well, if it's not a problem, let's take a look at the next big category, executables and mapped. We already had executables and DLLs in previous versions of Memory Profiler. However, well, you need to understand the difference because before Unity 22.3 and Memory Profiler 1.0, it actually was kind of fake because previously it showed you just a collection of binary files in your build folder, which obviously doesn't map to what your memory consumption is. And we upgraded it, so starting from Unity 22.3, it actually shows you in the same way as operation system sees it. So now it shows you all executable files, all shared libraries, all mapped files that contribute to your application's memory footprint as seen by operation system. So you can see them all listed in here. For example, yeah, if we look at it, yeah, at the top it will be OpenGL library, some frameworks, and the application executable. When you analyze this section, because this is like when we talked about Dodi, this is the section that kind of like affected by this the most, because if these files are just being loaded, we don't modify them, so the operating system always have a copy of it. So because whenever you like map a file, operating system just makes like the part which is being accessed, it being brought into physical memory. And because it's not dirty, and it's not modified, obviously, because that the data on memory, data in memory can be discarded at any moment. And well, that means that despite the fact that all of these contributes to your resident memory, it actually might not contribute to your out of memory issue directly, but it will contribute to your performance. Because as soon as you get to the point when you are close to well, maximum memory footprint that your operation system sets, operation system will start to discard stuff. But if you keep on accessing the file, it means like it will need to reload them and discard something else. So you will start experiencing performance regressions well before you hit the out-of-memory issue, and you need to look for it. Well, and for simplicity, we haven't included Dirty into Memory Profiler, because I think it just adds too much. But in most of the cases, Resident is always bigger than Dirty, and much better indicator of your application's healthy memory needs. So this again means that resident size, especially in particular in this case, is more important for analysis, well, as well as for Android runtime compared to allocated, as it's the part that operation system consider important to keep in memory. So, yeah, if we look at the again at the list for our application, it doesn't look like anything in particular is like super large, and well, probably you can get rid of OpenGL if you need OpenGL. So yeah, I mean, I did like an extra profiling just thinking about like what can be reduced, but in here, most of the time, apart from looking for SDKs tool like that you kind of like haven't expected to see, or too large Unity binary, which usually is a sign that you probably abuse generics without CPP. These kind of things, which are particular of interest in this category. But generally, just assume if you see too much resident memory in this particular category, it might need additional investigation. So the next big one is graphics. Well, if previous categories kind of like felt confusing because, well, what you need to look at, like some of them pre-allocated for you by person, so this one is actually the most confusing, so stay focused. First of all, just remember, memory profiler shows you only system memory information. So it never shows you what's on your GPU, which is kind of like, well, at this point you might feel like, well, it's strange because you have graphics. What about that? And that's the thing. Graphic isn't about GPU local memory. It's about what's actually in your system memory. And it's not about this infamous read-write enabled flag. So just, again, a bit of the theory. Why is that? There are two common memory architecture when it comes to platforms we work on. The first one is UMA. It's Unified Memory Access. So all graphics allocations are in system memory. So GPU shares memory with CPU, and it's called graphics stolen memory when GPU just steals memory from CPU. And the second one, obviously, non-UMA, when you have usually dedicated graphics card, which have dedicated memory. So, I mean, it's kind of like obvious with UMA, because we allocate from system memory, GPU shares memory with CPU, so, and it's all in system memory, no questions. So why then we show it for non-UMA platforms as well? The thing is when we have GPU with dedicated memory, usually on desktops, operating system needs to share that local memory between multiple applications. And the way it's designed so that at any given moment, operating system reserves right to evict any resources out of GPU at any given moment because it needs it for another application. And it's driver's responsibility to make sure that all the resources that your application needs will be maintained in a valid state. And what drivers do, they allocate memory for any resources that you use, which is being called like local baking store if you profile on Windows. I don't remember how it's called on macOS, but the fact is that drivers maintain kind of like shadow copy of your resources for cases when it needs to, or like it's being asked to evict all resources application associated with your application. So just keep in mind that even if it's not UMA, your application will receive these allocations, and they will be associated with your application and count towards your total allocated memory. And another kind of like nail in this is just, it's all kind of like hidden. So it's somewhere well within kernel, and we can see these allocations. So if we can see these allocations, well, we can track them, why and how we are showing them. We actually kind of like fake them, and that's why we now write, just to be absolutely clear, we write estimated. So we take information about resources we know has been allocated, like texture, width, height, bits per pixel, any additional information about format, and we estimate how much they should be, like how much we think they will be taking, how much memory they will be taking. So that altogether allows us to estimate how much memory has been allocated by graphics resources, and just to make sure that we not creating any additional memory. Whenever we do estimation, we subtract it from untracked, and that's why untracked have this asterisk next to it, just to indicate that we just made some magical compensation just to be able to show you this graphics memory. And because we estimated, we don't have any information about whereabouts of these resources in memory. And because we don't have information about their whereabouts, we can say how much of them are actually resident. So if you switch to resident view in Memory Profiler, to be absolutely truthful with you, we will just show you NA, just to indicate we don't know how much of net memory is actually resident. And all of that memory will be counted towards untracked, because we kind of like, operation system reports you that this memory has been allocated, how much memory is actually resident, but we don't know who actually allocated it. So it doesn't spoil like total allocated, but unfortunately makes it like less informative. On the positive side, with latest Unity, we spent quite a lot of time to improve estimation code. So now it takes into account, well, I think like everything. Well, 3D texture, MSA, memoryless render targets, compressed textures, all of them now needs to be, I see, what I hope, estimated correctly. So even though they're still estimates, this information is quite useful if you need to estimate how much memory is being consumed by graphics resources. The next one is native. And native is so much easier compared to all the previous ones. So it's actually everything that Unity allocates for you outside of, well, not managed here, but inside of it. All Unity allocations, because we have like a memory manager would perform all allocation management inside of Unity. All allocations are labeled and pooled. So whenever you do allocation, we kind of like allocate inside pool, which if we don't have enough space inside pool, we allocate another chunk and allocate inside of that chunk. That's why you can see reserved, because, well, we allocate chunk, we allocate inside of this chunk. So some of that space, despite the fact that the operation system thinks that it has been allocated, is not being used by anything. So it's being reserved and will be used the next time you allocate something. And as well, like probably you've seen reserved previously on summary view, we moved it in here because in breakdown view now, because now you can get into reserved and see which allocations, which allocators in particular, well, are being not properly used, I would say. And I have to mention that whenever you allocate these particular sessions, probably as well as like resident, which is directly information about like your memory footprint, allocated is as important because all of these objects are quite often used, and allocated is like a very good indicator of how much resident memory your applications need to function properly. So even if though it's like not 100% resident, expected might be at any point. And talking about our Android game, well, the only part, like when I analyzed it, which looked suspicious, was reserved in particular because, well, it's quite large, to be honest. So, as I mentioned, well, now you can just expand it to see what's in there. And as you can see, the biggest offender, a log profiler. You won't see it in actual release game. It just means that profiler needs to do allocations to function, and that's what caused this particular allocator to expand. the second biggest is alloc default. This particular probably a bit more troublesome because usually, well, you allocated something that caused Unity memory pool to expand, and then you released it. Theoretically speaking, if you released everything in the chunk will be released, so it's not like monoheap, which never contract. But if you mix together like long-term and short-term allocations, it means like the chances of your memory fragmentations are quite high. So if you have like a 16 megabyte chunk and have like 8 byte allocation inside of it, this chunk will still resides like, you can say like in memory, but being marked as allocated. And it probably won't affect your resident memory size as much. But as you, like I mentioned that anything at any particular time might become resident. As you can see, quite a significant part of resort is actually resident as well. It's just the indication that it was used just a moment before we took the snapshot. We kind of provide information how to customize this, so it's not like completely unactionable, but unfortunately, probably like you need to have deep understanding about how Unity Memory Manager works to do it properly. Well, you can try, like we have documentation page about memory allocator customization, which allows you to do that, and there would be a link at the end. But, well, you can do that, but to be honest, I discourage you from doing that because probably you will do, you might do it, like, make it worse. So the next category is managed. And that's well known, and we talked about it a lot. The managed category shows you all allocations related to mono or LCPP virtual machine. I won't go much deeper into the detail. As I mentioned at the beginning, I think it's pretty well described. So just let's go briefly about like what you can see in here. And the first one is virtual machine. It's any allocations which mono or LCPP makes to maintain its internal state. Resort, in this particular case, slightly different from the previous. It just manage heap have sections which are not being used, so anything not being used by managed objects, but inside like manage heap goes into resort, and well, managed objects is just managed objects, like the thing you allocate in C# or we allocate for you. There's interesting bit about this section. As you can see, well, it's not big, but it's 100% resident. Why is that? It's the way Boehm garbage collector works. What it does, it kind of like scans your memory, looking for pointers of objects to make sure that it can mark objects as alive. So it means like it actually touches everything all the time and makes sure that all of your managed heap is actually present in physical memory. So keep this in mind. And actually, that's why like maybe like just targeting managed heap is just managed heap is not such a bad strategy because if you like scripts heavy, which many games are, this usually is the biggest offender. Well, not in our case, but still. And if you're interested just in managed objects, I would recommend you to use Unity Objects View because it allows you to just laser focus on just managed objects. And it does provide you a bit of extra functionality to quickly find like duplicates or just look at the view differently. And the last category I want to talk about is untracked. Let's talk about like what are the most common sources of untracked. So why we get this? The first one is, well, as I mentioned at the beginning, thread stacks. In our particular case, it's not that large because, well, Android is not as generous as just Ubuntu probably. So in our case, it's just 8 megabytes, which is pretty healthy. But as I mentioned at the beginning, different platforms does things differently. Sometimes you can see a lot in untracked just because it falls into thread allocation. The next is I want to mention third-party plugins and third-party libraries allocation used by third-party libraries used by Unity, which do allocations. Not all libraries provide us functionality to override allocator, and if we can't, unfortunately, allocations go into Untracked as well. But if you use third-party plugins, we now have API which lets third-party plugins to use Unity Memory Manager to kind of let us track these allocations, but not too many plugins actually use it. But so most often, if it just all these plugins use normal allocation functions for C++, like malloc, new, you will see in here it's called heap or add-on libc malloc. It depends on how it was managed through libc or system heaps. But generally speaking, yeah, that's usually the way they look. And well, as we talked about graphics, I mentioned that graphics allocations can be tracked, or well, whenever you have resident memory view, so make sure that you understand that whenever you switch to just resident side, or whenever you allocate it in resident or resident, all your graphics resources will be shown as NA and will go into somewhere in here, most commonly private. Sometimes you have, well, for example, dev Mali in this case. That's Mali GPU, because we're on Android. On iOS, you will see I/O accelerator, because in here we show you different tags. And these tags are coming from operation systems. So some operation system provides you functionality to kind of name allocations and or associate them with certain subsystem. It unfortunately not very actionable, but provide at least some information about what these memory, who could have allocated this memory. So it's last resort. So we haven't found anything in monoheap Unity allocations or executables. So let's show you at least something. Maybe because you have much more context about your game, so you might guess what these allocations are. So we talked a lot about quite significant time about Untracked, and well, unfortunately, if all these tags doesn't help you much, what you can do. So the only option you have in this case is just native platform tools. I don't want to go deep into how they work inside. I just want to list them just in case if you decide to use them. So on Windows, it's Windows Performance Recorder, Windows Performance Analyzer. It's slow and not very user-friendly, but allows you to profile user and kernel memory allocations, so you will see graphics allocations as they happen, and it's totally free. On Linux, Intel vTune, and I was mentioned during the previous talk that .trace actually allows you to profile on vTune and should be working with Unity as well. But everything else I tried is actually crashes or doesn't work with Unity at all. On macOS, iOS, obviously, Xcode instruments, nice instrument and work out of the box. On Android, you have Android Studio. Unfortunately, you need to have rooted phone to get it work properly. So it might work, but most of the time doesn't, unless you have rooted phone. So let me jump into summary because we're quite close to the time limit. First of all, resident memory is the key. Use the new resident memory column for memory footprint analysis, and it's your source of truth about what is in physical memory. It also helps you predict out-of-memory issues because you're in trouble if you're close to 60% of your target device physical memory. It might vary between different platforms, but general rule is that if you're close to that limit, first of all, you will start experiencing performance issues because a system will start to actively manage what is in physical memory. And secondly, some platforms will just have hard limit about how much memory you can use. Mind the context. As I mentioned, each category needs to be looked at. So there is no a silver bullet. Different categories require different approaches. Sometimes you need to pay attention to resident only, and ignore allocated entirely. Sometimes both are kind of important. So remember, the moment you touch any object, it becomes resident. And with so much focus on resident, you might wonder why we keep allocated at all. So for example, it kind of works as mental bridge. If you allocated 1 megabyte of memory, and you want to see this 1 megabyte in tool of memory profiling tool, just to understand that this is exactly the object you have allocated, and that allows you to kind of build the mental bridge. Oh, this is the object I allocated, and that's how much actually memory is being taken in physical memory. And obviously, resident memory doesn't work with graphics allocations, and if we want to show graphics allocations, we need to keep allocated as well. And use memory profiler 1.1. It provides more detailed and correct information compared to older versions. You can use it even with older snapshots, so it doesn't require you specifically latest Unity. It just gives you much more information with latest Unity, but you can use better and updated UI even if you are on Unity 2019 something. And well, as I mentioned, use Unity Objects View if the only thing you are interested in is memory heap, is managed heap. Because in this case, it's much simpler, much more focused, and it will help you with simple cases. These are the links I mentioned. Well, 1.1 package, allocator customization, my blog post about memory footprint, and my colleague post about Unity Objects View and how to inspect object memory. Thank you very much for being present here. And yeah, do we have time for questions?
All right, hey everybody, welcome to the talk. I'm glad to see so many people are excited to learn about how to build for visionOS with Unity. And without further ado, let's get started. So just a quick intro, my name is Matt Schoen, I'm a software engineer. I've been working at Unity for about 7.5 years. Before then, I started an indie game studio called Defective Studios, making first and third-party games and apps with Unity. So my journey with Unity has gone a long time. When I joined Unity, I started working at Editor XR, then Project Mars, the AR companion app, and now I work on the PolySpatial team, bringing visionOS support to Unity. Just a quick notice that the lawyers asked me to put in here. Everything we're talking about today is forward-facing, experimental packages, things may change. I ask you please don't base any purchase decisions or consider anything that you see here as set in stone. These are evolving technologies, and things may change since this talk. So, I want to give you guys a brief overview of what you're going to see today. You're going to see an introduction to Apple's visionOS operating system. You're going to see how we've created support for visionOS with Unity. I'm going to bring Pavel Polatsky on stage to talk about some of the experiences that Resolution Games has had porting their games made with Unity to visionOS. And then I'm going to share some helpful tips and tricks, resources, and things that you can use to get started today. So in case you haven't heard, Unity is excited to collaborate with Apple on support for the Apple Vision Pro and visionOS. As you may have heard at the keynote this morning, we are opening our beta to pro, industry, and enterprise users. That means anyone can go out today, download Unity 2022.3, download our packages for PolySpatial and visionOS support, and get started. So, let's talk about some of the foundational concepts that may be new to you or new to mixed reality in visionOS. And it's going to give you some context for how we've built support for these various concepts in Unity. So there's two types of ways that apps can present content to the user on visionOS. One is in the shared space, where multiple applications can present windows or volumes that contain 2D or 3D content, and users can reposition and open and close these volumes at will, much like the macOS operating system, where multiple applications can run and present windows to the user. There's also the immersive space, which is a way for apps to be able to create and present content in an unconstrained, unbounded way all around the user. An app can choose to open an immersive space, and if it is the foreground app, it will launch the immersive space. All other apps in the shared space will fade away, and you will be immersed in this singular app with windows, volumes, and objects all around you. So as a brief demo, I'm going to switch over to the visionOS simulator, which is part of Xcode. Again, you can go out and get the Xcode beta today and get this on your Mac and play around with it. So as you can see here, the simulator window I have open shows you what you might see in a Vision Pro device with a virtual environment. I can two-finger click and drag to look around. I can use the WASD keys or a two-finger pan to navigate the environment. Again, if you're familiar with our AR simulation, XR simulation features in Unity, this is very similar, or some of the other simulator apps that are out there. I have the home screen available here. I can kind of like swipe back and forth to look at the apps that I have available. I should have mentioned, the way that you would do this on a Vision Pro device is by gazing at a particular affordance, pinching your fingers, and moving your hand around. So this is kind of the point and click or a touchscreen tap equivalent for the Vision Pro device. So you see here I have apps that I can launch much like an iPhone home screen. I can gaze and tap on an app and it'll be presented to me in a window. There are these other affordances that I can use to use the freeform app. And then there is this Chrome at the bottom that I can use to reposition. You see it sort of goes transparent as I move it around. The one thing you're missing here is that you can also push and pull in mixed reality to move the app further in and closer to you. There's also an affordance that will show up when you gaze at the corner to resize and scale the window. Again, these should be familiar concepts to a windowed operating system, much like macOS. On the device, I could press a crown button to open the home screen. In the simulator, it's up here. Again, we'll see the home screen. I can go launch another app, say like Photos. And here we have two apps existing side by side. So you'll see that as they overlap, the background app will be faded out. I can interact with another app and bring it to the foreground. Again, this is how computers work. But this is how computers will work in mixed reality. Finally, I have an app that is basically just the Xcode template project that I've built here to demonstrate immersive space. So it launches in a volume. As you can see, there's just like a sphere that sort of is floating in space as well as this small UI. And it, again, will fade out the apps behind it and coexist in the shared space. You can't really read it here, but this affordance is called Show Immersive Space. When I click on that, all the apps fade away, and now I have these two extra spheres representing your immersive content. And this is what happens when apps will transition in and out of the immersive space. I can turn this off again, and then here you see my apps are all available. I also just want to point out that I'm not the source of truth on this. Obviously, this is all Apple software and Apple operating systems, so the best source of information for that will be the WWDC talks from back in June. 2 of them were co-presented by people from Unity, so they'll be particularly relevant, but I also encourage you to just kind of go and browse and learn more about visionOS from Apple. Going back to the slides. Let's talk a little bit more about the shared space. So apps can use volumes to show content, and users can reposition these volumes as you've seen. Users can interact with the Chrome on the volume itself, as well as the content in the volume. So the app that I showed you with the sphere wasn't interactable, but those little slider toggles were. And again, this would all be done by gazing and pinching. There are also some other accessibility options that you can use, like a wrist-based ray or that kind of stuff. Again, go see Apple for the real authoritative information here. As well, apps can open and close an immersive space. So this is like an option that the app will elect to do or not. As you saw, when it opens the immersive space, all the other apps will disappear. You can place content out around the user without any kind of constraints. I should mention that the volume gives you a constraint where you ask for like a meter by meter by meter cube. If your content veers out of that cube, it will be clipped. You'll see a little bit more of that in later demos. And also importantly, when the immersive space is open, ARKit features are available. So what are the ARKit features on the device? There is a new feature called hand tracking that will give you skeletal tracking of all of the joints of your hands. And then some other features that you may be familiar with from ARKit on phones, room meshing, plane detection, image detection and tracking. One more that I'm not remembering right now. Oh, head pose, so like camera tracking on a phone, and of course hand tracking that I mentioned. I should also note that not all of the ARKit features that are available for phones are available in visionOS at the moment. This may change in the future, but for now you're limited to those 5. Finally, there are 3 different sort of modes or types that the immersive space can take on. A full immersive space is like virtual reality. It completely overrides the pass-through. Again, you'll see another example of this later in the talk. And that is, there's no access to pass-through. The user's hands can poke through the pass-through, through the virtual content if you so choose, but it is a lot more like a traditional virtual reality app, no pass-through. Mixed reality blends content with pass-through, so you can have sort of both simultaneously, like you saw in that example that I showed you. That was a mixed mode immersive space. And then finally, a progressive virtual space is kind of a mix of the two. There is a virtual background as well as mixed reality content, and the users can dial that little crown button on the device to essentially change the field of view of that virtual background. So they can have a little bit of a background or elect to be completely immersed. So with that out of the way, now you know a little bit more about visionOS. Let me talk about some of the application types that Unity exposes to you in order to target this platform. So there are 3 application types. The first one is mixed reality. So mixed reality is, again, like what you saw in the simulator, except rendered with Unity. And there's the caveat that in this mode, Unity uses Reality Kit to render, while all the other Unity features like physics and animation and things are handled by the Unity player itself. I'll dig into this a little bit more, but this is sort of the main driving factor for this new technology called PolySpatial. And it enables Unity content to be rendered on the visionOS with pass-through. Virtual reality should be much more sort of familiar to XR devs in the audience. You do have access to metal rendering. It is a build target just like anything else, and most / all of the existing packages that you're familiar with, like XR Interaction Toolkit and AR Foundation, as well as the render pipelines, will work in virtual reality mode. And then finally, a windowed app, which is very much like an iOS app. If you're using the existing touchscreen API, visionOS Gaze and Pinch is forwarded through the app as touch input. It renders into a 2D window like the Notes app that you saw, or sorry, the Freeform and Photos app that I showed you. And non-XR content that's built with Unity should be able to port to this mode very easily. So let's dig a little bit more into the mixed reality mode. It blends the physical and digital worlds, so you can put your virtual content on top of the pass-through, using some image-based lighting, the physical-based material from RealityKit. In order to make this as seamless as possible, what we've done with PolySpatial is mapped the Unity standard and URP lit materials to the physically based material in RealityKit, as well as some other kind of simple mappings that you can use to render your Unity content with RealityKit. But I'll get a little bit more into the caveats there in a bit. As I mentioned before, there's immersive space and shared space. Unity apps can also take advantage of these two places. So in the Unity editor, we have this component called the volume camera. It defines whether you're in a shared or immersive, whether you would like to put the content in that volume into a shared or immersive space. And you can swap the mode on that from bounded to unbounded. And as I mentioned, when you have an immersive space open, ARKit data is available to you through Era Foundation. Okay, so let's talk a little bit more about PolySpatial and how Unity renders in the shared space. So as you can see in this diagram, on the left side we have the Unity simulation. This is what you should be most familiar with. You can do physics. The assets are built into the player. It is a normal Unity build, but for this new build target, visionOS. And then Unity PolySpatial bridges the gap between Unity and RealityKit by taking transforms, renderers, materials, definitions for colliders, and replicating that in RealityKit with RealityKit entities. And then from there, RealityKit takes it from there. It uses image-based lighting. It uses other features of the operating system to render your content in the virtual world and in a way that it can be faded in and out and all the things that you saw in that earlier demo. And then finally, PolySpatial's RealityKit component sends back input events from the gaze pinch interaction, as well as the AR data and other kind of data from the operating system back to Unity. Other integrations like audio and internet access and those sort of things work just as they normally do on iOS. Unity has direct access to those parts of the hardware. Finally, I wanted to share some pro tips or just kind of individual little things to take note of when working with PolySpatial and mixed reality apps. If you have custom shaders that are written in our shader lab or HLSL language, you will need to convert those materials to shader graph. This is because we can enable custom materials in RealityKit using a technology called Material X, but in order to convert shaders from Unity to Material X, they need to be presented in a node-based format. This is going to be one of the most major challenges for porting existing content to the mixed reality space, but we're doing our best to kind of give you all of the workflow improvements and helpful things that make this porting process easier. There's also a project validation feature that is already used by a lot of the existing XR plugins and packages. This will give you kind of a feedback in terms of your project settings and things about your active scene and anything like that give you that guide you toward configuring your project correctly. I really advise you to check those out. And then we've also added some new rules specific to PolySpatial, not just visionOS, to help you understand things like particle systems or terrain and LOD, some of these rendering features that are not fully or maybe not partially supported. I should mention in terms of feature support, things like post-processing effects or anything that uses a full screen render target are just impossible in mixed reality on the platform, so they're not supported and they won't be in the future. Other features like I mentioned, terrain, trees, LODs, that kind of thing, those can be supported in theory, we just haven't kind of gotten there yet. And you can refer to the documentation for the PolySpatial package online for a more detailed breakdown of supported, unsupported features. Moving on, we've introduced a new type of interactor for the XR Interaction Toolkit. The XR TouchSpace interactor, which is in the PolySpatial.xr package, gives you a kind of more direct route to do interactions with a gaze and pinch gesture. It avoids having to do a raycast within the Unity scene because visionOS will give us the specific RealityKit entity that was targeted by the interaction, and we can kind of backpropagate that to the game object that was being clicked on, and that gives you a kind of more direct interaction path. All of that is provided for you in the PolySpatial package, but if you're using an existing scene with XR Interaction Toolkit, you'll want to bring in this interactor on top of your existing setup. The next thing is kind of just good general advice for Unity, especially on mobile platforms or things that kind of aren't the standalone Windows, Mac, and Linux platforms. I encourage you to start small, small scenes with not very many assets, projects that build quickly, things that you can test often. Basically, there will be some issues that you encounter along the way, and it's much easier to recognize, fix, remediate those things early on in the process with a small project that is simple and kind of easy to narrow down. Also, if you run into trouble, like app crashes or unexpected results, please go check out the FAQ and the general documentation online. The FAQ should run down a lot of kind of like, common snags and trouble points. And as well, obviously, the documentation will give you lots of information about the features that you want to use. And I also encourage you to explore the templates and samples that I'm going to give you an overview of later in the talk, just to kind of get yourself familiar with what's possible in the platform, how to set things up, best practices, that sort of thing. Now, I'm really excited to show off this feature. This is something that I've kind of always wanted for Unity development, and it's enabled in a unique way with PolySpatial and visionOS. There's a feature that is new to this latest release of the package that just came out today. It's called Play to Device. It allows you to press play in the Unity editor and immediately see your content and your app appear either in the visionOS simulator or on a device. It streams the PolySpatial data over the network. The Reality Kit on the device presents your content to you, and input and data is streamed back to the editor over the network, giving you this tight integration and fast iteration. So you can deploy using Play to Device without building through Xcode, and you can access play mode features like the inspector or the transform handles and that sort of thing. So hopefully this will work. I got a live demo prepared for you. You know how these things go. All right. So back here in the visionOS simulator, I'm going to close some of these apps that I opened earlier. I'm going to open this Play to Device app, which you can download through our discussions forum, or on the device there is a test flight link on the discussions forum as well that you can use to install the app on a device if you have access to it. It's going to give you a kind of helpful piece of information that you're ready to connect, and this is the device's IP address. Since this is a simulator, I can just use localhost. But I'm going to go back to Unity. I'm going to go to the PolySpatial menu, open the Play to Device window, and you'll see here I already have the option checked to connect the player. I can leave the default localhost IP address, but if I was testing on a device, I would use the IP address I see here. And without further ado, press play. Hey, there we go. All right. So as you can see, yeah, all right, come on. All right. So as you can see here, I have my volume in visionOS. I can move around and kind of see what it looks like from different perspectives. I can interact with the content in here, and you can see it both replicating in the editor and on the simulator. I can also go back to the editor and do these interactions in play mode as well in the game view. I can look at things in the scene view, kind of have these extra controls. These are interactable objects, so I can't really move them around without them freaking out. But you can see here also I have the inspector, so as I show these two things side by side, as I operate and move this object around, you'll see the data changing in the inspector. And I can also go and do things like modify materials. Again, basically anything you can do in play mode, you can do with Play to Device, and you'll see exactly what it's going to look like on the simulator. Just to milk this demo a little bit more, I'm going to show you a different scene. And again, I can start and stop any play mode session I want. I can move the volume around and sort of play around with those features. You see here we have some animated characters showing off. And as well, I can go and use the scene view and make some tweaks to my scene if I want to. So again, we're really excited to show off this feature. I've always wanted this kind of thing for Unity for mobile development and things. So it's really great to see this kind of improvement to workflow and iteration time coming out of PolySpatial. So that went well. All right, I got my backup video that you don't even need to see. So that was mixed reality and PolySpatial. Now we're going to kind of transition to the second app mode, virtual reality. So PolySpatial is not in the loop here. All you're doing is using the xr.visionOS plugin provider for XR Foundation, XR Management, sorry. And this allows you to render with metal, so those constraints that I mentioned earlier about rendering features and converting to shader graph do not apply to virtual reality. But unfortunately, you don't have access to pass-through video. So it is a kind of choice that you have to make when you're deciding how to target the platform. Do I want to go ham with my custom shaders and stay in virtual reality, or do I want to take advantage of pass-through and use Reality Kit for rendering? Another caveat that's easy to miss is that unlike a lot of the other XR platforms, you need to have an AR session in your scene for virtual reality to work. This is because, as I mentioned earlier, the head pose, where the user is looking, is exposed through ARKit. There needs to be a running session. The way that we expose that to you in Unity is through AR Foundation and the AR session component. So a lot of kind of like first timers will say, hey, my content is headlocked. Why am I not getting input? It's because you need the AR session. Oh, right, I also have a VR demo. So let's go back to the simulator. So again, just like with mixed reality, VR also works in the simulator. I have here a VR app that I built earlier. Man, this demo was pretty reliable before. Let's just try this one more time. Well, okay. I would be showing you our beautiful new URP Japanese garden demo. I'll see if there's a little bit of time later to like restart the simulator and try that again, but the app isn't launching. I got all excited about the demos working. Okay, and now finally there are windowed applications where without any of the PolySpatial or XR plugin packages in your project, if you target the visionOS platform and build, you'll get an application rendered to a window like you see here. It's almost identical to an iOS app. It uses touch input, it renders with metal, and it will exist in the shared space in a single window. No options for immersive spaces or anything like that. Obviously, you'd need to use PolySpatial to enable those features. All right, so and as I mentioned, we have some resources for folks to get started today. The first is the visionOS template. So there is a new template for visionOS specifically. We will probably end up kind of merging this with the mixed reality template as a whole, but for now, they're still separate things. It is available through the discussions forum. You can download a zip, and it is a full Unity project with some sample content and two sample scenes, one set up for a bounded volume-based interactions, one set up for the immersive space. All the project settings and package setup and all that kind of stuff is pre-configured, so it's the best way to kind of just get out of the box and start going. And we will also be putting out a template for VR. At the moment, you should be able to just flip the app mode for the MR template and test out virtual reality as well. Furthermore, there are some samples in the package itself that you can get through the Package Manager UI. It's a bunch of sample scenes and the assets and content that kind of drive them. The first scene is a project launcher with this kind of nice little aesthetic with the preview of each scene in these little bubbles and some UI to switch between them. You press the arrows, you press play, you launch into a particular scene. In the middle here, we see the object manipulation scene. That was the one that I was using in the Play to Device demo. Just some basic cubes that you can pick up, toss around, see what object manipulation looks like. And finally, the balloon gallery demo is kind of my favorite one. It's almost a full-fledged game. It uses input, it has particles, it has audio, it has kind of, the score tracking and stuff. So just really integrates a lot of the different features and shows you what a real game might look like in mixed reality. And of course, Unity has a wide variety of tools and workflows that aid development for virtual reality and mixed reality. The XR simulation feature that's part of AR Foundation allows you to test in the editor in play mode features that are based on mixed reality or augmented reality features like meshing, planes, image tracking, etc. The XR device simulator that's part of the XR interaction toolkit will let you simulate hand interaction specifically with the skeletal mesh that you get from ARKit. And then also the XR Interaction Toolkit comes with a variety of demos, templates, and sort of like building blocks that you can use to get started in a sort of a more advanced interactions right out of the box. All right, so with that, I would like to welcome Paweł Polaczki on stage to talk about Demio and resolution drawings.
Okay, hello everyone. My name is Paweł Pilacki. I'm a senior MR developer at Resolution Games. I've spent the last 3 years driving Demio to the various platforms like 2D, virtual reality, and mixed reality. Since my dive into HoloLens in 2017, I've been immersed in the world of mixed reality, captivated by its potential and possibilities. I'm very excited about the Unity's PolySpatial technology and how we'll expand Demio to the rich new platforms. So what exactly is Demio? Demio is a captivating cooperative adventure game for up to 4 players. It recreates the joy of tabletop gaming with friends as you work together to vanish evil forces. Demio demands strategy, teamwork, and offers 5 unique adventures in the fantasy world. Demio extends its reach across various platforms, offering the choice of both immersive and 2D experiences, while seamlessly enabling crossplay between them. Now, with the new visionOS platform, we can blend both worlds together. Here, you can see a short example of the gameplay and our mixed reality integration to the other platforms. Our game allows you to seamlessly transition from VR to mixed reality. The game is 100% playable with the hand tracking, and you can instantly switch to the controllers if you want to. So now let's explore the visionOS, a platform that offers diverse ways to launch and enjoy the game. Given that the Demio is available in both VR and 2D, introduction of the windowed mode was a natural decision. Best way to approach that is having the game working on the iOS platform. Porting to this mode is a straightforward process, and this is primarily because the mobile touch inputs seamlessly transition to the visionOS. Users can leverage both hands to control the game. The game will work exactly on the other platforms, except use the hand tracking and eye tracking to manipulate it. The most fun in the game is definitely in the VR, when you can totally dive into the different Demio adventures. It's pretty easy to make sure that the game looks good in the full VR, thanks to metal rendering. Here, we don't really need to care about the environment reflection props or the lights, which is very convenient. Since initially we used the built-in render pipeline, we didn't get the forward rendering out of the box, but I will chat about this a little bit later. So last but not least, the mixed reality mode, where you can leverage both bounded and unbounded mode. Running the game with Reality Kit is very challenging, and what Unity done here is really astonishing. In terms of visual design, we are still trying to figure out how to leverage the environment lighting while preserving the original look and feel of Demio. One of the Demio features is the ability to move and scale yourself in the game. Within the gameplay, players can dynamically move directly into the battle. And previously, on the other platforms, we achieved that by adjusting the player avatar. However, with the PolySpatial, we have something called volume camera, and you can control that to kind of scale and rotate and move your world. There is a lot of potential going from unbounded to bounded mode. Just imagine that the game switches to the shared space, and now we have freedom to do all the other cool stuff that Vision Pro allows us to do. And the game is just add-on to our real world, and the game just blends next to it. So let's talk a bit about particles. They are the most challenging aspect of the PolySpatial technology, and only utilize a fraction of Unity's particle systems. So in case of Demio, while all VFXs rely on custom shaders, like conventional methods become nearly impossible for us. So to address this challenge, there is something new solution from Unity in the PolySpatial package, something called bake to mesh, where the particles actually are baked in runtime each frame to the meshes. This method allows us to implement custom shaders, but it's not working that is still early in the development process. since Demio initially was built with the built-in learning pipeline, we had to start the process of porting the shaders to the URP. And as you can imagine, our tech artists were super thrilled about this, since like we have few hundred shaders, yeah. So in our conversion pipeline, we use the Unity shader graph. And it's because it validates the shaders in terms of the reality kit support. And it's super useful to see quickly like which nodes of your shaders are not supported, or if the shader is exceeding the reality kit limits. And by porting to URP, we also gain the foveated rendering, which is really crucial to kind of keep the performance of the game and also manage the battery gameplay time. Because like playing the single adventure of Demio with your friends can take up to 3 hours, and it's nice to not lose your battery. Here you can find some example of how the game looks and before and after porting to URP. And as you can see, there are not many differences. So like shout out to our tech art team. So let's talk in summary what kind of advantages we gain. So we are pretty excited about using hand tracking combined with eye tracking. Like playing Demio with your hands or controllers can be really tiring. And being able to use the eye tracking and just having the hands in the relaxed position is really convenient, and like you can play more comfortably than the other platforms. As you might know, that we are using crossplay among all platforms which we support, and we are happy to find out that the photo networking is working really nice still within the visionOS. Having bounded, unbounded, and windowed mode allow us to give this player an option how to launch the game and just enjoy the mode they prefer. And we also are exploring how to leverage the AR kit to feel the game be more immersed. For example, during the gameplay, you can throw the die each turn, and it would be super nice if like the die could bounce among your floor, but also like the furniture and kind of stuff. When it comes to challenges, well, particles were the obvious one, and we are still in the exploration phase how to solve that. The in-game voice chat is not working currently for us, and this is because of some microphone access issues, but this might be also outdated knowledge because like the beta is changing so fast and there is a lot of fixes. It will be also super nice to leverage the environment lighting, because it's really tempting to like having your, let's say, board pieces like affected by your real light, and like having the MR mode really immersed, like the game feels almost physical. So will the MR mode look like the VR? We will see in the future. Thank you so much for your attention, and back to Matt.
Yeah, just leave it. All right, thank you, Pavel. So really that's all we had for you today. As I mentioned before, today we announced that the beta is open to Pro, Enterprise, and Industry subscribers. If you get Unity 22.3.11 and above, you can integrate those packages using Xcode 15.1, Beta 1, and above to build. And as a note, the simulator requires an Apple Silicon Mac, so actually being able to test your build is going to require Apple Silicon, but you can still develop on other platforms. There we go.
Is that available, or do you still need to submit your content to Apple?
The Unity beta is available to all Pro, Enterprise, and Industrial subscribers. Access to Apple's Developer Lab, we'll need to talk to Apple about that. But you can go to this page here to learn more about how to integrate the packages, get the right version of Unity, et cetera, and build the simulator today. That's our time. Thank you, everyone. Hope you enjoy the rest of your show.
What is up, everybody? Before we get started, oh yeah, can I get another woo? Woo! That's what I'm talking about. Before we get started, I just want to say thank you so much for attending today's session. We've got a lot in store for you, and we're thrilled to show it. Now, today's breakout session is called Prototype a Game Level in 20 Minutes with Unity Muse. And in this session, we're going to cover everything from what in the world is Unity Muse to the demos that actually showcase just how powerful, just how game-changing this product can be. Now, one key theme I want to call out is that Muse is here to accelerate your creation process. And we even put it to the test by timing the creation process in some of these demos. Pretty cool stuff, right? Now, as an introduction, my name is YJ Gong. I am a senior technical product manager at Unity. I'm also the product lead launching Muse Sprite, as well as Muse Texture. We thought it would be fun to throw in some details about our journey, a fun fact, as well as what game we're currently playing. So my journey is that I'm a former special education teacher, turned aspiring lawyer, turned product manager. And the common thread line throughout my career has always been about empowering people, and in this case, empowering creators. My fun fact is that I am a T1 esports fan. Any esports fans here? Yeah, there we go. And the game that I'm currently playing is Spider-Man 2. I got a yay. I haven't gotten to the part where I encounter Venom, so please, no spoilers. Alex, would you like to introduce yourself?
Hi, I'm Alex Reed. I'm the engineering lead on the Muse Texture and Muse Sprite for the machine learning side. My journey was actually, I was building a game with my daughter, and we couldn't find the textures we wanted. It was a long time to get everything. So I built a tool to help us create textures. That tool became Barium AI, and now I'm continuing that work at Unity. Fun fact is I love building IoT gadgets, hardware devices, automation, all kinds of stuff. And we really play too many games together to name, but the main ones are Space Engineers, Raft, Slime Ranchers, and all kinds of stuff.
Awesome. Thanks, Alex. Now, I also want to take a moment here to acknowledge the team behind the two tools that you're going to see today. Thank you, team, for the amazing work that you do every day. Now, if I may, I want to take us back in time for a moment here. Unity became what it is today because they simplified game development, right? And now we're here to say that we're continuing this and possibly maybe make it even more exciting than it already is with generative AI. Introducing Unity Muse. Now, what is Muse? Well, I want you to think of two things. One, generative AI. Two, a toolbox. I'll say it one more time. Generative AI and a toolbox. Oh yeah, I see someone going like that. Yeah, there you go. Thank you very much. That was great. Now, I want to slow down here for a moment and talk through this slide because it may just be the most important way to understand Muse. For all the Unity users who want to accelerate productivity regardless of skill level, with Unity Muse, our users can leverage a collection of generative AI tools to rapidly and scalably produce customizable assets in the context of their Unity game environment. Now, there are a couple key words to call out here. One, rapidly. With Muse, we want to, again, accelerate your productivity. Two, scalably. We want you to be able to scale your asset creations in a matter of seconds. Three, customizable. The assets that you create should fit your vision. It should match the style needs of your game. And then finally, four, regardless of skill level. Muse is for anyone at any level. In the end, our North Star has been a simple but powerful goal, and that is we want to give our users AI superpowers to accelerate their productivity. Now, there are two tools that I want to call out today out of the generative AI toolbox that we have called Muse. The first is Muse Texture, and the second is Muse Sprite. We'll start with texture. Now, textures can really be anything, right? There's an infinite variety of textures. By the way, all the textures, most of the textures that you see here were generated by Alex's 5-year-old daughter using Muse texture. Pretty cool, right? And it's these textures that help create the compelling and exciting worlds that you see in games today. But as one user describes it, the process of creating and exploring textures is slow, and it's painful. But what if in a matter of seconds, you can generate a rich variety of textures? What if by simply dragging and dropping it into your scene, you go from an untextured scene to one that is completely textured? Here's your first look at Muse texture. Let's say you want to prompt for a rainbow-colored slime, hit generate, and in a matter of seconds, you get rainbow-colored slime textures. Let's say you want paving stones. Same drill. Punch that into the prompt, hit generate, and you'll get that texture. Let's say you want red tile. Hit generate, and you will get red tiles. Now let's say you want something a little more exotic, like metal slime. Throw that in there, hit generate, and you get metal slime textures. Now generating is one thing, but artistic control is a whole other thing. And so we made it a point to provide features so that you can edit and customize the textures that you generate. Alex will dive into those details in the demo. Now here is an empty scene. It's a pretty cool scene, but the floors are empty, the walls are empty, the ceilings are empty. Now, what if you can take that texture and simply drag and drop it into the scene? So you can do that with the wall as you're seeing here, and it goes by really fast. Really just takes a second, right? Now, as you generate more textures, and you drag and drop all of them into the scene, you're going from one that is completely untextured to one that is now completely textured in a matter of a few minutes. Pretty cool stuff, right? Now, let's switch gears and talk about Muse Sprite. Sprites are what makes games games, right? You play as sprites, you interact with sprites. By the way, these were all generated using Muse Sprite. Now, I'm curious to know, by a show of hands, do we have any folks who participate in the beta program? Yes! That's what I like to hear. Awesome, so you guys will know this story. So during the beta program, we hosted several bi-weekly webinars. And in one of the webinars, we generated one thing, but using our Sprite feature called Doodle, we ended up with something a little bit unexpected. So here's Alex prompting for a chicken sprite. You hit generate, you get a couple chicken sprites. You also see Alex trying to draw a little doodle of the shape to guide how these next chicken sprites are going to be generated. Now, one user said, I see a laugh. Now, one user said, hey, that looks like a chicken doodle, yeah, but it looks more like a dinosaur. So we leaned into it. We gave it a pair of arms and prompted for a T-Rex chicken. We hit generate, and in a matter of seconds, boom, the T-Rex chicken was born. And if that wasn't enough, we took it one step further. We decided to prompt for a rainbow-colored T-Rex chicken. And there you have it. So the whole point is this. With Muse Sprite, you can generate something that is familiar, but you can also generate something that is a little different, a little new. And so I'm here to announce that starting today, we will have T-Rex chicken pop-up shops all over the world. I'm obviously kidding, but wait for it. We do have T-Rex chicken stickers that we will be giving out after this session. Pretty cool stuff, huh? Awesome. Now, we're about to switch gears again and go into the actual demos. And in this demo, we're going to showcase Muse texture. And the demo's purpose is to texture a 3D scene in under 20 minutes. Now, to make sure everyone's following along, I created a little bit of a cheat sheet, and I'll talk through them. First, we have the generate feature. The generate feature is pretty straightforward. You create a texture with just a text or image prompt. 2, you have variate. Generate variations of what was already produced. Again, this whole idea of being able to scale, right? 3, in paint. Draw over the parts of the texture that you feel like needs to be corrected, and then generate the corrected versions of them. And then 4, upscale. Increase the resolution of the texture from 512 pixels to 2048 pixels using AI. And then finally, reference. Provide a reference image to guide the shape and the color of your generations. Alex, over to you.
Thanks. So on the left here, you see the default HDRP demo scene, and on the right is Muse texture. This is actually me texturing this, and just keep in mind, I'm not a technical artist, I'm an amateur. So I just start out prompting for some concrete and some dirty concrete. I find one I like of each, so I convert those to material. I noticed there was actually after tweaking the map there, there's a little blemish that I come back and fix, but you can see, you can just quickly adjust the maps if they're too intense or not intense enough. And also likewise for the dirty concrete here. So I was happy with those, enough to try them in the scene. And we're 20 seconds in and we already have 3 materials here. So yeah, so testing them out in the scene, I wasn't exactly happy with how they tiled. You could see some of the imperfections. So I play around with the settings a bit. And they're more apparent there. So I come back and the dirty concrete was actually not too bad. So after trying to fix the blemish on this one, I still wasn't happy with it. So I do upscale the 2K, the dirty concrete to 2K resolution. But what you're seeing here is our refinement and our in-painting feature. So you can regenerate specific spots of the texture if you're not happy with them. So yeah, I still wasn't happy with it, so I went with the dirty concrete upscaled now. And at this point, so you don't have to sit around for 19 minutes watching this, it's sped up. So yeah, while that's upscaling, I moved on and I wanted some nice brown square tile floor. So you just prompted for brown tile using the pattern feature. So with the pattern feature, we provide a bunch of pre-created patterns, or you can supply your own pattern. And the generation will follow it very closely. So yeah, at this point, I've had the upscaled dirty concrete, so I was happy with that. Started applying it to the rest of the scene here. But at this point, I noticed that the brown tile had a bit of a grout line missing, so I try a couple more. And I ended up with one that was had a bit more color variation. It looked a lot nicer, and the grout was pretty good. So that would be the third one here. So it's still, at this point, we're only a few minutes in. We've already got 7 materials. Yeah, same thing, moving on to the frame for the plant box. I was aiming for some kind of aluminum or steel with a bit of worn look to it. But it was directly under the lighting, so I wanted the tiling density to be a bit higher so that if you look at it closely, the shadows look very nice. And the first one you can see came out with a pattern that was really visible when you repeated it, so I tried a bunch more. This is the beauty of this, you can try as many times as you want. Yeah, tweak the material just a little bit, and it came out quite good. Yeah, so I was happy with that. I used the same thing for the trim on this room here. And now I start adding some color to the room, so I wanted some gold for the railings. I was actually happy with the first one that we got, even though I generated a bunch. and also applying it to the railings down the hall in the other section of the room. Yeah. So at this point, I wanted a bunch more color where you will see the red tiles that you've seen before, and also some copper for the divider between the rooms. I actually spent a good amount of time on the copper, probably a fifth of this entire recording was spent messing around with the copper. It's got, on the back side of that divider, there's some really intense spotlights. It took a lot of adjusting to get something that I really liked. Again, we're at like 14, 15 minutes in, and we have almost the same amount in materials. Yeah, and I was pretty happy with that. So then I moved on to the final room, and there's great lighting in this room, so I wanted something quite reflective. And the materials I had already created before looked pretty good on these props, so I went with that. The only exception was the tiling on the frame of the chair. So just keep in mind, everything in the scene is UV unwrapped in a way that works really good with seamless materials. So these are all seamless materials. So yeah, adjusted a little bit for the frame, got some nice fabric for the chair. And of course some white marble to interact really nicely with the light and get the good reflections in from HDRP. It's awesome how quick the room can come together with just one material. Yeah, but this last section here was offset a little bit, so if I had reused the marble, you would be able to see a visible seam, so I went with a red carpet in this case. So at this point, it has been 19 minutes of recording time, and the entire scene is textured. And that's close to 20 different materials that were exported. So. This is what I can do as an amateur. I would really love to see what all of you can do as professionals. I do.
Pretty awesome, right? All right, so we're going to switch over to another demo. And to Alex's point, what happens when you put this tool into the hands of a professional artist? I want to spotlight one of our beta users. His name is Hugo Caustic. He is the founder of Far From Here Studios, based out in France. He's also a technical artist as well as a generalist game developer. Hugo used Muse Texture to create an incredible world, and we thought it'd be great to showcase that today. So Hugo, thank you so much for allowing us to showcase your work. Alex?
So what you see here was built by Hugo in 2 evenings, just over a weekend. The entire world was built from scratch. He sculpted all of the terrain. Every texture you see here is made with Muse Texture, with the exception of the 3D foliage. Even that dragon you saw on the shield was made with Muse Sprite. So he used multiple different techniques, including like texture projection, vertex painting to apply the moss here, also the moss on that big skeleton you saw earlier. And this is, for just 2 evenings of work, really amazing. Definitely better than anything I could build myself. So really, really awesome work, Hugo. Thanks for letting us show this.
2 evenings. Pretty awesome, right? Yeah. Thanks again, Hugo. Awesome work. Now we're going to do one more demo, and that is create a 2D scene in under 20 minutes using, in this case, Muse Sprite. Alex had created this scene with the assistance of his 2-year-old, right? This time? Yep, his 2-year-old daughter. Now, I want to call out 5 key features as a little bit of a cheat sheet once again. The first 3 you're familiar, but I'll still talk it through. You have generate, being able to create 2D sprites with a text prompt or reference image. You have variate, generate a variation of what was produced or supply your own image as a reference. You have inpaint, draw over the part of the 2D sprite that you don't quite like, that you think needs to be corrected, and then generate corrected iterations of them. And the last 2 are quite interesting. So you saw the doodle feature with the T-Rex chicken. So with the doodle, you can hand draw a doodle to accompany and guide a text prompt to generate your 2D sprite. And then finally, style. This one's a big one. Train the style generator to create the assets that match the look and feel of your game. And Alex will dive into that as well. Alex, right back at you.
So like YJ said, I had a 2-year-old sitting on my lap for this whole video. And I am also not a 2D artist. I've done very few 2D scenes, so everything was built at the request of my daughter with the exception of me adding a couple extra things. So she wanted a game where you could feed and pet and wash a horse. So we start with just a basic empty barn, and she wanted a brown horse. So we tried out a couple variations, and she picked this one out. And she immediately wanted food and stuff for it, but we needed some props to put the food and things on. So we go for some barrels. After the barrels, we do some crates, some boxes, you'll see. And keep in mind, this is probably the 3rd or 4th 2D scene I've ever made in my life. Yeah, you can actually see there's an animal in the box, and that was because the style that this was done in was trained on Happy Harvest, only on the animal sprites. So when you're using this tool, you can supply your own sprites. It will learn the style. They don't have to be sprites, they could be images as well. But it will learn the style of what you supply. And everything you generate will bias towards that. So yeah, you can see here, she wanted some soap for washing the horse, but the one that we liked had some weird text artifacts on it, so we inpainted those out. And again, you're seeing a few animal artifacts mixed with the brush. So we turn the style strength down. So when you train the style model, it works in tandem with our base model. So you have to find a good balance depending on what you're generating. So we got a brush that she was happy with. And she wanted a potion, so why not? So yeah, here you go. We're fixing up the potion with some inpainting. And of course, you have to be able to feed this horse. You cannot forget the food. So yeah, we generate some carrots and some apples. Yeah. And just a little tweak on the stem, and it's good to go. And this whole thing took 17 minutes, real time. What'd you?
17 minutes. Awesome stuff. Okay, now to recap. What can Muse do for you? Well, it can help you create infinite variations in a matter of seconds. It can give you artistic control. That's quite important here. So make AI work for you using more than just words. Work in the scene. Context is everything. I'm sure a lot of us here can relate to this one. Customize creations to match the style of your game. And ultimately, give yourself AI superpowers. That is Unity Muse, and we're just getting started. Thanks, everybody. We love to stay in touch with our users, so if anyone wants to reach out, these are our LinkedIn profiles. Feel free to scan the QR code and reach out. We'd love to get in touch. Thanks again. Enjoy.
And that concludes Unite 2023 APAC On Air. Let us know your favorite Unite session. As a long-time Unity user myself, it's always inspiring for me to see the engine evolve. And on that note, we'll conclude today's session. Thank you for watching with us, and have a great evening.
You got what it takes to go head-to-head? Prove